Pak Hakam, monggo.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of
mohon Bu
heroism
Mardia dimasukkan
underlies
ke
the new
breakout room.
generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including scientists, INSIS, vocation, creatives, MarTech, electrics, plan, interdisciplinary school. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With the spirit of heroism, ITS brings the future before us. ITS, advancing humanity.
Institute Technology Sepuluh November Surabaya, as one of Indonesia's leading universities for study and research, is built above 180-hectare land, currently accommodating 18,484 active students, 1,094 lecturers, and managed by 1,561 staff members. Launching program Smart ICoCampus at 2011, ITS is fully equipped with integrated technology. Students can learn and interact through Smart Class program by simply log in at the designated time for an online class session. Massive open online courses, MOOCs, are free online courses available for anyone to enroll. All accessed by smart cards, application, web and mobile site. Smart ICoCampus is also implemented by building an eco-farm to obtain environmental-based lifestyle. ITS is providing iCar, an electric self-driving car, with 20 stopping points utilized by iCar app. Campus Bike to simplify student mobility around campus. Supply with best facilities, students can live comfortably inside ITS campus. Starting from excellent student dormitories, canteen and cafeteria at various places, K1 Mart to shop daily needs, canteen and cafeteria Manarul Ilmi Mosque, accessible toilets for disabled people in every area, various sports facilities, indoor and outdoor fields, accessible toilets for disabled people in every area, a medical center as health service unit, sports facilities, indoor and outdoor fields, language and culture center to boost English competence, ITS library, and several co-working spaces as a learning resource center. ITS provides more than 184 laboratories spread across 7 faculties. Among them are the Robotics Laboratory that has pioneered research, development and education, and already successfully winning national, regional and international robot contests. Robotics team built Robot Medical Assistant, RAISA, to reduce the workload of medical personnel and minimize the exposure of viruses. The Energy and Environmental Laboratory was the main task to support ITS main research and provide consulting, analysis, and training services. Material and Energy Laboratory, equipped with the latest machinery to help students learning to determine product and material quality control. Architecture Laboratory provide places for students to design, produce, and refine their architectural artistic creations. Geomatics Laboratory is utilized for mapping survey to support the geospatial information industry and natural resources management. ITS Techno-Science as a place for ITS to contribute to the industry by collaborative learning to support technological innovation and commercialization, business creation and employment development, economic development, which all incorporated in Science Techno Park. High technology in line with natural environment makes ITS beautiful and comfortable, important to create a supportive learning atmosphere for the students.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including scientists. Insist. Vocation. Creatives. More tech. Electrics. Shift plan. Interdisciplinary school. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With the spirit of heroism, ITS brings the future before us. ITS, advancing humanity.
Recording in progress.
Saya turun lagu ini pas waktunya sudah mulai kan? Itu MC mas? Sudah MC? Sudah. Ayo mas, stepnya mas. Aku jalur kekuasaan. Gak apa lagi. Yes. Tak buka MC ya? Iya, sudah siap. Karena berdua oke kan bodoh. Kurang pas berarti pakai mas. Ini mesti pas. Sudah dikasih tahu aku fungsinya aku. Ya bu.
Good morning, ladies and gentlemen. Welcome to the International Conference on Mathematics, Pure, Applied, and Computation, or ICoMPAC 2021. To October 2021 at Institut Teknologi 10 November, Surabaya. My name is Samarah Rana.
Miran, suara kamu tuh. Sama buka. Sudah.
We are truly sorry for the inconvenience, and my partner here is Admiral Litik. It is our pleasure to be your masters of ceremony for today, and we are very honored to be here with all of you. The distinguished ITS Rector, Professor Dr. Insinyur Muhammad Ashari, Master of Engineering, the Honorable Martianus Frederick Ezerman, PhD, the Honorable Professor Makato Yamashita, the Honorable Professor Dr. Muhammad Isa Irawan, Master of Technology, and all of our beloved ICoMPAC 2021 guests and participants. Before we begin, let me deliver our agenda today. First is the opening, followed by the National Anthem of Indonesia and Hymne ITS. Next, we will proceed with the speech from the Chairman of ICoMPAC 2021 and ITS Rector, followed by mathematics student product videos and video profile of mathematics department. The next agenda will be the keynote speaker presentation, and then we will have an hour break. Next, we will proceed with the parallel class session, and last but not least is the closing ceremony. To begin, ladies and gentlemen, please enjoy the following ICoMPAC kaleidoscope video.
Oke, Pak, ini sudah dimulai. Berikutnya saya close ya, mungkin bisa dikerjakan. Oke.
Next, let us stand up for the national anthem of the Republic of Indonesia, Indonesia Raya, followed by the hymn of Institut Teknologi 10 November, Himne ITS.
As mentioned, let us proceed to the welcoming speeches. The first one will be delivered by the chairman of ICoMPAC 2021, Dr. Tahiyatul Asfihani, MSI. To Dr. Asfihani, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. The Honorable Rector of Institut Teknologi 10 November, Dean of Faculty of Science and Data Analytics ITS, Head of Mathematics Department ITS, all keynote speakers, Martinus Frederick Ezerman, PhD, Profesor Makoto Yamashita, Profesor Muhammad Isa Irawan. Ladies and gentlemen, on behalf of the ICoMPAC 2021 Organizing Committee, I'm honored and delighted to welcome you to the 7th International Conference on Mathematics, Pure, Applied, and Computation. The ICoMPAC is organized by Mathematics Department, Institut Teknologi 10 November. Due to the COVID-19 pandemic, the ICoMPAC 2021 held virtually. On this year, the topic of this conference is mathematics of quantum computing. We are so pleased to accept 49 papers. Our program is plenary sessions with 3 keynote speakers and parallel session divided into 5 parallel classes. We appreciate and recognize outstanding papers by awarding the best papers and the best presenters. This conference is the result of the hard work, support, and dedication of some parties. Thanks to all the committee members who together make the conference possible. Thanks to Institut Teknologi 10 November, Nanyang Technological University, and Tokyo Institute of Technology for their contribution to this conference. Last but not least, I would like to thank for all participants and reviewers of this conference. Thank you for being here with us. Enjoy your participation in the ICoMPAC 2021. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Aspihani, for the speech. The next speech is to be delivered by Director of ITS, Professor Dr. Insinyur Muhammad Asari, Master of Engineering. To Professor Asari, the time is yours.
Ladies and gentlemen, from ITS from Surabaya, Indonesia. The Honorable Chairman, speakers, and distinguished participants, on behalf of ITS, Institut Teknologi 10 November, I would like to congratulate and welcome to the International Conference on Mathematics, Pure, Applied, and Computation, or ICoMPAC 2021, which is organized by Department of Mathematics, Institut Teknologi 10 November, ITS Surabaya. This ICoMPAC 2021 is held as part of our 61st anniversary of ITS. ITS is one of the best university belongs to Indonesia government. Currently, we have 23,000 students and 8 faculties. This includes a Faculty of Science and Analytics Data, or in the short name we call it Faculty of Scientifics. The Faculty of Scientifics covers Department of Mathematics. ITS now in the position of the first place according to Times Higher Education Impact Ranking in Indonesia in 2021, or the position is 64th world ranking, especially for impact. The impact ranking launched by Times Higher Education means that our campus has a very high concentration, a very high commitment in implementing SDG, Sustainable Development Goals. ITS, also known as the best science and technology university in Indonesia, particularly the best three in Indonesia according to Times Higher Education World University Rank 2021. Ladies and gentlemen, as we know, the role of mathematics is vital in many aspects in our life. There are many problems arise in social, in business, economics, environment, and many others that could be solved with mathematics. So recent development of mathematics relates to knowledge with quantum computing. So this relation between two fields gave a major contribution in solving many problems in our life. So I'm sure ICoMPAC will be the flagship conference for researchers, students, and professionals in the area of mathematics and its application. Last but not least, I wish all participants have a very interested and learning experience during the conference. Moreover, I hope that new collaboration among participants could be established. To our foreign guests, I wish you have a memorable meeting in our conference during this pandemic. If we can visit Surabaya City, welcome probably next time and enjoy the environment of Surabaya. So during this online conference, again, we welcome you to visit through online our website to our university, but also we hope we welcome you anytime to visit physically to our campus. ITS, Institut Teknologi 10 November in Surabaya, Indonesia. Thank you very much.
Thank you, Professor Ashari, for the speech. Next, we would like to invite Professor Hamzah Fansuri, PhD, to open ICoMPAC 2021. To Prof. Hamzah, the time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, the Honorable keynote speakers, Dr. Martianus Frederick Ederman, Professor Makoto Yamashita, and Professor Isa Irawan, and also distinguished participants and chairpersons and all the committee to this 2021 ICoMPAC, or International Conference on Mathematics, Pure, Applied, and Computation. As the Dean of Faculty of Science and Data Analytics, I welcome all of you to this conference. Although in the pandemic situations, that makes us only can do it through online meetings. But I hope that this conference, online conference, can give us better place, better communications among us, among researchers, among scientists, to improve the knowledge, improve the better life of humanity, and it is very aligned with our new ITS theme, which is advancing humanity. Yeah. Surabaya now is in good weather, although it's warm. But if you come to Surabaya at this moment, our tabebuya is flourishing. Tabebuya is a plant, yeah, type of plants, which is flourish during hot weather, warm weather actually, and therefore we actually miss all of you participants, and also we all actually hopes that we can meet physically, but because of the pandemic, we cannot do that. We have to do it online. This morning or today conference themes is the quantum computing. I believe this is the very interesting topic. Yeah, where we believe that quantum computing is the next level of computing. The method to make computations process much faster and can do many things that cannot be done by what I call as traditional computing methods. Please correct me if I'm wrong, yeah, or what we've been doing here. So it is, of course, a very interesting topic to be discussed today, and we have a excellent speakers this morning, Dr. Martianus Frederick Ezerman, and Professor Makoto Yamashita, and of course, Professor Muhammad Isa Irawan. I hope that all participants can enjoy this conference and get a lot of information, knowledge, and of course, the networking. Yeah. Then this conference will get the success today and move smoothly until the end of this day. Because the MC asked me to officially open this conference, I don't want to take more time, so we can start earlier this conference, and by saying Bismillahirrahmanirrahim, I'm officially open the ICoMPAC 2021. I hope all participants enjoy this conference and get good communications, good discussions, so take as much information and as much knowledge as possible from all participants, especially for our honorable keynote speakers. That will give speech today. Thank you very much from me. Assalamualaikum warahmatullahi wabarakatuh.
Now, before we continue with our keynote speaker presentations, we would like to invite our honorable guests and participants to capture this wonderful occasion through a photo session. Please kindly activate your Zoom videos for this photo session. We will wait for a couple of minutes until the participants and all honorable guests are ready. I would like to remind all honorable guests and participants to turn on your camera so we can start our photo session in advance. Okay, since most of the participants are ready, I will count to 3 and our committee will take the photos. As we have more than 2 slides to be taken, please keep smiling until we finish the photo session. For the first slide, please be ready. 1, 2, 3. Moving on to the second slide, please be ready. 1, 2, 3. And finally, the last slide. 1, 2, 3. Now we have finished our photo session, and now let us watch the following videos before we proceed to the next agenda. The first video is the Mathematics Student Creativity Program product video.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang Bapak Ibu dan teman-teman. Kami dari Institut Teknologi 10 November dengan judul PKM Aplikasi Berbasis Android sebagai media konsultasi bisnis untuk startup secara interaktif. Yang beranggotakan Nurmilatul Afidah, Alianus Sabrina, Ramadan Sanyoto, Rian Kurnia, dan Syafiq Bari.
Selanjutnya, penyebab utama kegagalan startup yang paling sering ditemui didasarkan pada laporan Survey Insight yang dikumpulkan dari laporan postmortem atau pasca kematian adalah sebagai berikut. 42% gagal karena tidak dibutuhkan pasar, 29% gagal karena kehabisan dana, 23% gagal karena tidak menyusun tim dengan tepat, 19% gagal karena kurang mempertimbangkan kompetitor, dan 18% gagal karena sulit menyeimbangkan antara harga dengan biaya. Nah, untuk menjawab permasalahan tersebut, solusi apa yang Digibis tawarkan? Yang pertama adalah layanan jasa konsultasi. Para customer dapat berkonsultasi dengan konsultan terkait permasalahan yang sedang dialami bisnis mereka. Kemudian, customer juga dapat memilih fitur-fitur yang disediakan pada aplikasi Digibis sebagai media konsultasinya. Dan yang kedua adalah pencarian investor. Pada aplikasi Digibis, kami juga menyediakan fitur pencarian investor untuk bisnis yang kekurangan dana. Bisnis kami menargetkan 2 pasar utama, yaitu UMKM dan startup bisnis yang masih baru. Untuk UMKM sendiri, kami berfokus ke bidang kuliner dan fashion.
Senyum kak kayak tak aja tutupan gitu.
Dibandingkan dengan kompetitor, kami memiliki keunggulan yaitu adanya fitur video call, live chat, dan layanan home service dan layanan investasi.
Menurut hasil wawancara yang telah dilakukan pada tanggal 9 Februari 2021, selama pembelajaran daring, nilai rata-rata pelajaran matematika dari kelas 7A hingga 7E mengalami penurunan. Di sisi lain, siswa-siswa SMP saat ini sangat gemar dalam bermain game. Hal ini dibuktikan dengan hasil survei yang telah kami lakukan dan menunjukkan bahwa siswa SMPN 52 Surabaya ini sangat suka bermain game. Lalu, bagaimana cara mengatasi permasalahan tersebut? Berdasarkan studi literatur yang telah dilakukan, kami memodifikasi metode TGT dengan menggunakan media game online berbasis teknologi online mobile Android, sehingga tim PKM dengan dosen pendamping Dr. Imam Muklas SSIMT dengan Ketua Lulu Wardatul Jannah dan 4 anggota lainnya mengusulkan program kreativitas mahasiswa dengan judul Game Edukasi Online berbasis Teams of Game Turnamen sebagai inovasi media pembelajaran matematika untuk meningkatkan kreativitas siswa SMPN 52 Surabaya.
Dan ada pemberian video tata cara upload soal dan game serta tata cara penggunaan game pada siswa dan guru. Selanjutnya, ada simulasi yang dilaksanakan 2 kali pada tanggal 18 Agustus 2021 secara online melalui Zoom. Kemudian diikuti oleh 3 guru matematika dan 2 guru IT. Dengan teknis pelaksanaan dijelaskan secara singkat penggunaan game, kemudian guru masuk pada breakout room yang berbeda, dan di dalam breakout room terdapat 1 anggota tim yang menjelaskan secara langsung dan mensimulasikan secara langsung game elastik.
Kami dari kelompok program kreativitas mahasiswa Riset Eksakta 69 yang beranggotakan 4 orang, yaitu Revi, Nanda, Elnora, dan Adila, serta dosen pendamping kami Bapak Muhammad Iqbal. Pada riset ini menerapkan sistem Smart Predictive Maintenance pada pabrik semen dengan menggunakan metode deep learning. Sebelum masuk pada metode LSTM dengan model yang akan dibuat nantinya, maka prediksi terkait klasifikasi status diagnosis dan prognosis mesin harus sudah memiliki label pada masing-masing status. Tahap pelabelan ini kami lakukan secara hybrid dengan online serta offline pada bulan Juni minggu kedua sampai minggu keempat. Proses pelabelan menghasilkan 2 label, yaitu untuk status diagnosis normal dan rusak, sedangkan label untuk status prognosis yaitu berfungsi layak dan tidak layak fungsi. Dan didapat akurasi kemiripan dengan data asli yang sangat tinggi, yaitu 96,34% untuk mesin Raumil dan 81,5% untuk mesin Kilin. Tahap ini dilakukan secara online pada bulan Juli minggu keempat sampai Agustus minggu pertama. Hasil yang ditunjukkan oleh model status diagnosis dan prognosis yang dibentuk sangat baik. Nilai loss yang dihasilkan juga kecil, di mana pada time slice 10 second memiliki performansi yang lebih stabil. Untuk akurasi yang dihasilkan pun sangat tinggi, yaitu lebih dari 99% untuk kedua mesin, yaitu mesin Raumil dan juga mesin
Next, we will show you the video profile of Mathematics Department. Please enjoy.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including scientists, INSIS, vocation, creatives, MarTech, electrics, Plan, interdisciplinary school. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With the spirit of heroism, ITS brings the future before us. ITS, advancing humanity.
Institute Technology 10 November Surabaya, as one of Indonesia's leading universities for study and research, is built above 180-hectare land, currently accommodating 18,484 active students, 1,094 lecturers and managed by 1,561 staff members. Launching program Smart ICoCampus at 2011, ITS is fully equipped with integrated technology. Students can learn and interact through Smart Class program by simply log in at the designated time for an online class session. Massive open online courses, MOOCs, are free online courses available for anyone to enroll. All accessed by smart cards, application, web and mobile site. Smart ICoCampus is also implemented by building an eco-farm to obtain environmental-based lifestyle. ITS is providing iCar, an electric self-driving car, with 20 stopping points utilized by iCar app. Campus Bike to simplify student mobility around campus. Supply with best facilities, students can live comfortably inside ITS campus. Starting from excellent student dormitories, canteen and cafeteria at various places, K1 Mart to shop daily needs, Manarul Ilmi Mosque, accessible toilets for disabled people in every area, various sports facilities, indoor and outdoor fields, a medical centre as health service unit, language and culture centre to boost English competence, ITS library, and several co-working spaces as a learning resource centre. ITS provides more than 184 laboratories spread across 7 faculties. Among them are the Robotics Laboratory that has pioneered research, development and education and already successfully winning national, regional and international robot contests. Robotics team built Robot Medical Assistant, RAISA, to reduce the workload of medical personnel and minimize the exposure of viruses. The Energy and Environmental Laboratory was the main task to support ITS main research and provide consulting, analysis and training services. Material and Energy Laboratory, equipped with the latest machinery to help students learning to determine product and material quality control. Architecture Laboratory provide places for students to design, produce and refine their architectural artistic creations. Geomatics Laboratory is utilized for mapping survey to support the geospatial information industry and natural resources management. ITS Techno-Science as a place for ITS to contribute to the industry by collaborative learning to support technological innovation and commercialization, business creation and employment development, economic development, which all incorporated in Science Techno Park. High technology in line with natural environment makes ITS beautiful and comfortable, important to create a supportive learning atmosphere for the students.
Departemen Matematika yang berdiri sejak tahun 1965 memiliki dosen yang sangat baik dan berkompeten pada bidang aljabar, analisis, matematika terapan, dan ilmu komputer. Dengan reputasinya yang sangat baik tersebut, kami dipercaya bekerja sama dengan Delft University of Technology, Vienna University of Technology, Sibaura Institute of Technology, dan juga Oxford University. Selain program sarjana, kami juga mengelola program master maupun doktoral.
mahasiswa dalam kegiatan akademik dan non-akademik. Dengan dukungan tersebut, mahasiswa diharapkan memperoleh pengalaman untuk dapat mengembangkan diri.
Selama saya menjadi mahasiswa matematika ITS, saya sudah mengikuti berbagai macam kegiatan. Salah satunya yaitu sebagai panitia OMIT atau Olimpiade Matematika ITS tingkat nasional.
Untuk pengalaman Olimpiade, kebetulan saya beberapa kali ikut Olimpiade dari kampus lain, seperti Kalkulus Cup Universitas Negeri Jakarta, terus Olimpiade di Universitas Negeri Malang, UI, dan lain-lain.
Matematika ITS itu asik, dan di matematika ITS itu kalian punya banyak kesempatan untuk eksplorasi diri. Contohnya, selama aku di matematika ITS, aku punya kesempatan untuk eksplorasi baik bidang akademik maupun non-akademik.
Sebagai kasubag tata usaha umum di lingkup institusi yang memang stakeholder-nya adalah mahasiswa, jadi pelayanan yang kami utamakan dalam mahasiswa.
Departemen Matematika ITS memiliki berbagai macam fasilitas yang menunjang proses belajar mengajar. Di antaranya, laboratorium, ruang baca, co-working space, ruang kelas, dan ruang sidang.
Program ini berkorelasi dengan pusat penelitian yang ada di ITS, pusat unggulan yang ada di ITS, dan pusat kajian yang ada di ITS. Masing-masing laboratorium di Departemen Matematika ITS ini bertanggung jawab kepada mata kuliah yang ada di Departemen Matematika ITS, baik itu di S1, S2, S3.
Matematika ITS berkolaborasi dengan instansi lain yang menghasilkan beberapa riset.
Riset ini akan melakukan proses sortir peluru yang cacat menggunakan pengolahan citra digital. Secara garis besar, alat ini akan mengambil gambar atau citra peluru menggunakan dua kamera, yaitu bagian belakang dan bagian selongsongnya.
salah satu program tentang deteksi plat nomor kendaraan bergerak, di mana di sini aku menggunakan metode AI, Artificial Intelligence, yaitu tentang deep learning. Sekarang program ini masih dalam tahap uji coba berupa inputan data video rekaman. Diharapkan nanti program ini bisa mengerjakan inputan data secara real time dan bisa membantu pihak kepolisian dalam memantau perkembangan lalu lintas.
Departemen Matematika ITS merupakan salah satu departemen matematika terkemuka di Indonesia yang terakreditasi A dan memperoleh sertifikasi ASEAN University Network. Selain itu, Departemen Matematika ITS juga memiliki reputasi internasional dalam bidang matematika dan komputasi.
Ayo MC.
Ladies and gentlemen, we will now proceed to the keynote speaker presentations moderated by Sena Safarina, Doctor of Science. To Dr. Safarina, the time is yours.
Okay, thank you very much, admirer. So let me introduce myself first. Okay, my name is Sena and I will be a moderator for this session. Good morning to all speakers. Good morning, Dr. Ezerman.
Morning.
Okay.
Good to be here.
Thank you. Good morning, Professor Yamashita.
Yes, good morning.
Okay, thank you. Okay, let me check. Okay, good morning, Professor Isa.
Good morning.
Okay, thank you. Again, I would like to thank to all keynote speakers for your time and for your availability. And we hope that we can gain our knowledge from your expertise. So it seems that our lecturers are in good condition. Did you get vaccinated?
Yep.
Doctor, okay. So did you finish like second vaccinated?
Yes, last July already.
Okay. And how about Professor Yamashita?
Yeah. Yes, it's okay.
Thank you. And yeah, I think Professor Isa already got vaccinated. Okay. Okay. Before listening to the lecture, let me present all keynote speakers' profile. So, wait a moment. Okay, so let me introduce Dr. Matianus Frederick Ezerman. So he is a senior research fellow at NTU, Singapore, and his expertise is in coding theory and information theory and sequence. Okay, if you wanna if you want to know him more, so you can visit his homepage and also Google Scholar by typing Frederick Ezerman. And here is his experience. So okay, so he has so he already joined NTU from 2014, so as a research fellow, and continue as a senior research fellow. And also, he graduated from Manila University for his bachelor and master program, and from NTU for his for doctoral program. And here you can see the recent publications. So I think all of this relate to, I'm sorry, because because his expertise outside my field. So yeah, you can see, you can read by yourself. Okay, so that's all about Dr. Ezerman. And here, the profile for Professor Yamashita. So actually, he was my supervisor during master and doctoral program. So, okay, so yeah, he is from Department of Mathematical and Computing Science, School of Computing, Tokyo Institute of Technology, and his research is about mathematical optimization, mainly, or operation research, and continuous optimization, nonlinear optimization, and semi-definite programming. Again, so you can visit his homepage and Google Scholar if you want to know him more. Okay. So here, his experience. So he is a professor from last year, and yeah, you can see that he graduated from Tokyo Institute of Technology, and he was also a visiting researcher at New York University. And here, the publications. So you can see that his publications related to the nonlinear programming. Yeah. And the last, so I would like to introduce Professor Isa. So he is one of professors in our department. So his research is on machine learning or bioinformatics, data mining, and decision science. Okay, here is his experience. So you can see that he got some research fund on genetic for his research about genetic algorithm for function optimization with multiple variables, and he was working with some research related to the virus or antivirus here. So he graduated, as for education, he graduated from Vienna University and also Bandung Institute of Technology. Okay, so I thought that Professor Isa graduated from ITS, but yeah, actually not. Okay, so here his recent publications. So you can see that his publications are related to the genetic algorithm and also about some virus again here. So yeah, mainly about genetic algorithm. Okay, so that's all for their profile. Then for this session, so we will have all lecture first, and then in the end of this session, we will open Q&A. So please prepare your note and write all questions first so that you will not forget what you want to ask. Okay, so first, let us listen to the lecture from Dr. Ezerman. So please, Dr. Ezerman, prepare your slide. And
you want me to start? Okay.
Have your time. Thank you.
Okay, let me settle first. Okay. Suppose that's good. All right. Very good morning, ladies and gentlemen. Thank you to organizer for the kind invitation. I would really love to be there in person. Before COVID halted all travel, I traveled to Surabaya quite often, actually, at least twice a year. I grew up not very far from Surabaya. I grew up in Madiun and then in Blitar. And my wife also, my wife grew up in Blitar as well. So I go back to East Java quite often. Today, since we have 30 minutes, I'm just going to give you a very brief overview of quantum stabilizer. So this is a topic which is very close to my heart. Actually, I started learning about quantum codes in my third year of undergraduate. So this is a long time ago, I suppose 18 years ago. My undergraduate thesis is already about quantum stabilizer. Continue until, so the main topic of my PhD dissertation is also quantum stabilizer, but in a more complicated setup, in a more realistic setup. And every now and then I go back to quantum stabilizer because of requests to referee papers and give what you call it, a seminar and tutorial to graduate students. So it's still something that I do very regularly. It's an active area of research for me. Today I'll try to describe the connection by example. So I will explain just the basic concept necessary for us to understand, and then I will describe it with examples. Then I'll point out to you where, if you are interested to dig deeper, where you can find. So before we go into the main topic, I hope you can see I'm switching to an internet browser. And here I go into this webpage, codetables.de. This is maintained by a dear friend of mine, Marcus Grasso. We work a lot together. So if you click on the left here, QECC, that's quantum error correction code. And it contains here a record of best known quantum stabilizer codes that we have collectively as a community of researchers managed to produce over the years, okay? And later I'm going to use this one of my favorite small example right here. We're going to use this as an illustration. I'll explain to you more as we go along, but this is usually the place if a researcher think or claim that he or she produced a new code, a better code than before, this is the place to compare it, okay? And Marcus and I, with a few other collaborators, are also still generating new codes, and we are updating these tables from time to time. The two of my recent publications are actually in this area, but we are contributing toward the long end, around a 90-ish, around here, around length 83 to 90, 98, 99. So as you can see, there's still a lot of places where you have lower bound and upper bound. That means this is room for improvement. So it's an invitation to other researchers also to contribute. Let's say this one, the best known we have, the distance is 6, but the theoretical upper bound is 8. So that means there's still room for improvement. Either you bring down 8 to 7 or 6, or you bring 6 to 7 or 8, or you show that 6 is the best or 7 is the best. So things like that is still very much alive in terms of research. So what motivates the need for quantum error correction or quantum error control? Let me go back a little bit and start by the project of building quantum computer. This was explicitly mentioned as a challenge to the physics community in a speech by Richard Feynman. The speech eventually made it into a journal form, where he says, if we want to simulate dynamics in the quantum setup, then we better build quantum computer. And he outlined the main challenges. And then the community took it up and says, well, okay, so this is now the framework of doing quantum computing. This was the work of David Deutsch and many others. But the field really kicked off when in the mid-1990s, two algorithms were introduced to the community. One is Shor algorithm. Shor algorithm is saying, well, you can do factorization and you can do discrete logarithmic problem in polynomial time if you have quantum computer. And then Love-Grover is saying, well, if you have unstructured database, then you can do the search much faster in the quantum computer setup if instead of classical setup. So those two algorithms really kick off storm. Why? Because if you have large-scale quantum computer and you can implement those algorithms, then the current cryptographic standards that we are using are in great dangers. Of course, so far we are yet to see cryptographically relevant quantum processor, but then the motivations become very, very much practical. If you can build quantum computers, you can break current crypto systems. You can also do a lot of simulations, all sort of simulations. I suppose the other two speakers will touch on them. So then it motivates our search for systems that will make computing in a quantum processor reliable. And these results are collectively called quantum fault tolerant computing. Okay, so quantum error control, the one that we are going to look into today briefly, is a small portion of this big endeavor of coming up with large scale or even medium scale quantum processor. So what is the connection between quantum and classical in terms of codes? Okay, so let me start with classical codes. To define a classical code, we usually take as our alphabet set finite fields. Why do we use finite fields? Because we want to use tools from algebra, linear and abstract. If you have an alphabet set which is finite field, you can form vector space just by stringing the entries together. Okay, so you form FQ raised to n, and that is a vector space. And in vector space, you can do a lot of things. You can look at the subspace, you can look at inner products, you can look at linear transformations happening there. So a lot of things you can do. And because your underlying field is, alphabet is filled, then you can use tools from abstract algebra for that. So let me set up the playground. The playground is we use vector space FQN. Okay, the length is n. That means we are dealing with block code. Okay, if the code is linear, then we have we can express it as a subspace. Because it has a subspace, it has dimension, it has basis. Okay. Now, if you look at an element in this code, so this code now is a subspace, then you call the element there a code word. And you say that its Hamming weight is the number of non-zero entries. Very simple. You look at the entries of these code words and say, how many entries are non-zero? That's my Hamming weight. And what is the minimum distance? The minimum distance is you look at the minimum weight of the non-zero code words and then you take the minimum. Okay. So for the purpose of this lecture, I'm just going to use binary and quaternary. So F2 and F4, and that's how you express F2 and F4. Okay. This omega here is actually the root of x squared plus x plus 1 in F2x. Okay. I suppose everyone here is familiar with this expression. As I already mentioned, this is an inner product space. So then you can define inner product. Very simple. Let's say we have a binary playground, and then the code is of length 2n. So now I'm looking at the first n and the second n. And now I have two code words, v and w. Actually, it doesn't have to be code word. They can be vectors in the vector space f2 to n. And then now I can do the symplectic inner product. Symplectic inner product is I take the first n element here, I take the dot product with the second part of the other vector, and then I add it to the product of the second part of the first vector with the first part of the second vector. So, you know, it's like you split the length into two, and then you multiply the first part here with the second part, plus the second part of the first one with the first part of the second. Okay, and now we're switching the field. We're moving to F4. The length is n. We can put the trace Hermitian inner product. So now here our vectors are of length n, and the trace Hermitian inner product is simple. I will square the element in the second vector. Okay, I multiply it with the first one here on the left, and then I do the analog. Okay, so now a sub j times bj squared plus a j squared times bj. And this is what we call a trace Hermitian inner product. Because we have inner product, we can define dual. The dual of a code C under a valid inner product, so the inner product can be symplectic or Hermitian depending on the setup you have, is a set of all vectors that are orthogonal to all code words. Okay, so just look at orthogonality defined by the inner product, and then we say that the code is self-orthogonal if the code is contained in its dual. So if a code is inside its dual, we call it self-orthogonal. Now, what we will do here, we're going to see a connection between classical error correcting codes and quantum error control. Now, there is a common misconception. Many people, especially the beginners or those who just read it from the media, they say, oh, okay, we can use quantum error correcting codes, we can build them from classical codes. Not really. Because these two are very, very different objects, okay? Quantum codes live in the Hilbert space of complex vector space, okay? So it's a complex vector space equipped with the usual Hermitian product in physics. And classical codes live as a vector space over finite fields. So one is a very discrete object. Classical codes are discrete. Quantum codes are continuous, actually. So where does the connection come from? The connection comes from we use classical code to model error operators, and the duality properties of the classical code tells you how the error operators behave. So that's the main insight of this stabilizer code, actually. So the formalism says that if you want to stabilize a certain set of error operators, you can design the error operators by using classical code. And so the task to find good quantum error correcting codes can be translated into choosing classical codes that will design quantum codes that can handle a set of error operators. So you describe the error operators by classical codes, and now you say, well, the code that I want, the quantum code that I produce by using this model have the following properties, okay? So you translate the properties from classical to quantum by using this stabilizer bridge. So, okay, next question is, okay, I'm interested. How can I go deeper into it? So these are 4 basic references that I would recommend if you want to go deeper into it. And the lecture I'm giving you today is actually a very short version of a long tutorial I give in a SIMPA school in Turkey in 2018. So that is the link to the entire slide. If you want to look into the step-by-step derivation of the algebra, it's available there. Okay, so let's look at a bit from the physics perspective, okay? To express vectors and products, physicists use what we call the bra and cat notation. So a mathematician, especially discrete mathematician, a mathematician who are expert in discrete mathematics, discrete structures, when they read physics papers in quantum error correction, they often get very, very confused with the notation. So a cat like this is a column vector. So the notation comes from Dirac, and I must say, once I get used to it, I like it better than the usual vector notation in discrete math when dealing with quantum error control, because it's very, very intuitive once you understand it. So a cat is just a column vector, and a bra, which is the dual of a cat, is written with the left angle instead of with the right angle for the cat. Okay, so simple. Cat is a column vector, and a bra is just a dual. And the dual here is the Hermitian dual in physics. Okay, the inner product is written like this. So it's very simple. So the inner product of a cat and a bra, two cats, the inner product of two cats is simply written this way. And the tensor product is written this way. Quantum operators, they behave like, they behave in terms of a tensor product, okay, not in the usual product in discrete mathematics when we just look at the Hermitian or Euclidean product. So usually the tensor product, we even remove the middle part here. We just write it this way, okay? And this notation in number 5 denotes the Hermitian inner product of a cat and another cat. So how do you read a cat psi here? You read it, the operator A is acting on the state represented by the cat here. So this is actually equivalent to the inner product, to the Hermitian inner product of A dagger. A dagger is the conjugate transpose of A, okay? And applied to the state, the other state, the first state, and the second state. So when you look at the Dirac notations, you can translate it immediately back to the usual matrix notation or linear algebra notation in discrete math. Nothing mysterious or ingenious there. Actually. It's just physicists, they're much more familiar with the Dirac notation, and mathematicians are much more familiar with the usual inner product notations. So when you do quantum computing, right, you store the informations in terms of qubit. Qubit is quantum bit. So if you look at one qubit, it is a non-zero factor in C squared. So it's a complex. It's an object over the complex space, a complex field. So this is a complex vector space. Usually we denote the basis just as a 0 cat and 1 cat, okay? So this is in superposition. So what happened is with the probability modulus alpha squared, when you measure this qubit, you will get 0. And with probability modulus beta squared, you measure this, you will get the 1. Now you can extend this qubit into an n-qubit system. This is a non-zero element in this big space. So you see here the tensor showing up here. So then if you want to write an element in an n-qubit system, this is actually a tensor product like this. And you can write it nicely in number 3 here. So in terms of cat, this will be a linear combinations of all the basis element. And now the basis element here, look on the right-hand side here, is expressed in terms of vector space. So this A is actually a vector in a vector space. Okay, and so the probability of finding of measuring A1 will be the modulus of CA1 squared, and then therefore if you want to take the normalizations, right, because in physics you want the normalizations to be kept tabulated well, then here is just the sum of all the probability divided by the number of elements in there. This is to ensure that the sum of all probability will go to 1, you know. Now, but this normalization is optional in terms of quantum information processing, because we consider a ket, meaning a vector, and a multiple of that vector, we consider it to be the same state for non-zero complex alpha. So from now on, we will denote by I the square root of -1. Okay. Again, an error happened on a state. In classical sense, the error is just another vector in the vector space, which is not part of the code. But in the quantum setup, things are different. The error operators are unitary complex linear operator acting on the qubit system here, acting on this system bit by bit, or in this case, qubit by qubit. Okay, so it can be expressed as a unitary matrix. If you have quantum bit, then the error operator acting on that bit can be expressed by a unitary matrix. Okay, and the biggest good news actually is the following. You have a set of 4 operators that can describe all error operators that acting on a qubit. I'm writing here non-trivial. You are saying that, well, I see only 3 here, sigma x, sigma z, and sigma y. Yes, because the other one is identity. Okay, so 2 by 2 identity matrix complete the set of Pauli matrices. You can use these 4 matrices to express all error operators acting on a qubit. Okay, so the insight is that error operator can be discretized. You can treat them as complex linear combinations of the Pauli matrices. Okay, so those 4 basic Pauli matrices act as follows. Identity, of course, doesn't change anything. Sigma x is a bit flip error, so it changes the probability of 0 and 1. Okay, so if you write it in terms of vectors, this is just, you know, you change this column vector alpha beta to be beta alpha. And a phase flip, this is how it affects the probability. Okay, so it doesn't actually change the probability, because remember, probability is modulus squared. So the modulus of beta and minus beta is the same, right, when you square them. It's just that it changes the angle. And sigma y is a combination error. Sigma y is just a combination error here. Okay, 1 sigma x, sigma z. So you look at the relation, all of them are degree 2. So all these non-trivial Pauli matrices, you square them, you get identity. And sigma x and sigma z anti-commute. So they're anti-commute, they're simply anti-commute. Okay, now then what happened? The Pauli matrices act on 1 qubit. What happened about the quantum error operator that act on an n-state qubit? Well, you just tensor them. Okay, so now this omega j is one of the Paulis, and lambda is just a power, so 0, 1, 2, 3. Okay, a quantum error operator has this form. So on the first qubit, it's acting as omega 1, second qubit as omega 2, and so on. And this is tensor product, so the size goes bigger, 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 very fast. Okay, So a quantum linear operator is just a C linear unitary operator acting on the C basis. Remember, the cat can be expressed as a linear combination of the basis. So now to see the effect of error operator, you just look at the effect on the basis element. Okay? So that's essentially what is happening here. You look at the effect of the operators on the basis element. Okay, so now you collect all of these error operators, okay? You collect them. How many elements are there? 4 raised to the n minus 1. 4 raised to n plus 1. The plus 1 here comes from the power because you collect all the power. Where does this power come from? From sigma y here. Sigma y is I, omega x, omega z. So there is an I there. Okay? The most important thing is how do you take that product? The product of two error operators are just like this. So per qubit, you look at the usual matrix multiplications and then you tensor them across. And then you collect the lambda and lambda prime. These are the excess I coming from sigma y. Okay. So a very simple example, if E is I2 tensor sigma x and E prime is sigma z tensor sigma y, you can compute E prime and E prime E. And you can see here that they don't commute. Okay, so this anti-commute in this case. So, okay, so where's the connection now between this? Okay, between the quantum error operator and the classical code. Now, I'm going to switch to a new notation. If you look at error operator, I'm going to write it as I, lambda plus L, X, A, and ZB. X, A, and ZB are now element of F to N. Okay, so essentially, I'm going to check what happened qubit by qubit and tabulate them in terms of classical vector. So if the first part, so I'm going to construct binary vectors of length 2n. In the first n, I will check how many times sigma x happened there. And in the second part, I'm going to check how many times sigma y happened there. And so if you have identity, nothing happens. So the first part is 0, the second part is 0. Sigma x, the first part is 1, second part is 0, and so on. Okay? And the L here is the excess I that comes from sigma y. So what is the advantage of the new notations? The advantage of the new notations is that you see, sorry, I think, okay, there is a feedback. All right, okay, thank you. So the advantage of the new notations, if you look at whether two quantum error operator commute or anti-commute just by looking at this. So this is, again, this is the symplectic inner product we introduced at the beginning. So if this symplectic inner product is 0, then the two error operators commute. Okay? So now let's look at the examples. This is a 513 qubit code. It encodes one logical qubit into 5 physical qubits. Now, it stabilizes the set of error operators generated as tensor products of this error operator tabulated here. So let's take a look at the first row. The first row, sigma x happens here, but there is no sigma z. So this is 5 qubits, right? In the first qubit, sigma x happened. In the second qubit, sigma x happened. In the third qubit, sigma z. In the fifth qubit, sigma z. Okay? And you can interpret similarly. So in the last part here, first qubit, sigma y happened. Second qubit, nothing happened. Third qubit, sigma y. Sorry. Third qubit, sigma z. Fourth and fifth qubit, sigma x. So you look at all the C linear combinations of all the 4 vectors here, 4 operators here, and your code, your quantum code can handle all of those errors. Okay? So now, C is self-orthogonal with respect to the symplectic inner product. You can check it later. Okay, if you look at symplectic inner product, this code actually self-orthogonal. Okay? Now, if you want to express the code, you can express the code Q as an eigenspace governed by the error operator, which is generated by the 4 error operators, this one. So this G1, G2, G3, G4 come from this classical expressions. It becomes quantum expression. So your code Q is an eigenspace. That's the word stabilizer coming from there. So the code Q is designed so that if any of these linear combinations of this error happen, the code will be stabilized. The processor will be able to handle such operators. Okay? Now, for those of you who are familiar with F2 and F4, F4 is just quadratic extension. So you can express element in F4 as 2 bits in F2. Similarly, 2 bits in F2 will represent 1 element in F4. So the representation in F4 is very simple. You take the first element here and the first element on the second part, and that is 1 plus 0 omega. So that is 1. Okay? So it's just expressing this F2 with length 2n as F4 with length n. And what happened? What happened is that the code now becomes additive code, no longer linear. And now you have a shorter representation in F4. Okay? Now, so where does the research problem come from? The problem is this: we know a lot about classical codes, but when we do this translation to quantum code, what we consider to be good in classical codes is not always necessarily good in the quantum code. So now the calibration goes as follows. If I want to design good quantum codes, what type of classical codes do I need? What can I use from classical codes to set up good codes in the quantum world? So that is the big questions that has been open to us in the quantum error control community. So I hope this brief introduction gives you some idea on the interaction of the two structures, the classical and the quantum. Thank you.
Okay, thank you very much for Dr. Ezerman. So we can give applause for his lecture. So you can give applause virtually.
Thank you.
Okay, like you see this one. Okay, so that was interesting lecture. So I will remind all participants to, if you want to ask a question, so you can save or you can write your questions in chat Zoom. Okay. Once again, thank you very much for Dr. Ezerman. So, next, I will give time for Professor Yamashita.
Okay. Then I'd like to share my screen.
Okay, please.
Let me see.
Okay, we will open the question and answer in the end of this session. Okay, please have your time, Professor Yamashita.
Okay, can you see my screen?
Yes, I can see your screen.
Hi. Good morning, everyone, and thank you very much for the invitation to this conference. It's my great pleasure to give a talk in this conference. Okay, the second talk. So my talk is about more application side of quantum computing. Okay, and the title of my talk is Quantum Annealing for Balance Optimization Subset Selection. Okay. And this is a joint work with my former student, Ms. Hunter Kerr. Okay. Okay, so in this talk, we'd like to consider application of quantum computing to optimization problem that arises from experimental design. Okay. To consider the situation of experimental design, I'd like to explain a simple situation in this right figure. So when the new medicine is developed, the evaluation of its effectiveness is an important step. And in such a situation, usually we have to divide the patient groups into two groups. So a control treatment group and a control group. So the new medicine will be prescribed to only a treatment group, and we measure the difference between the two groups. And if the difference is significant, we can say that this new medicine is effective. So in such a situation, the division of the patient group is an important step. For example, if we choose the first patient and the third patient as treatment group, then the control group is composed by the second patient and the fourth patient. So the treatment groups are young people, so 20s and 20s. So even if we can find some difference between these two groups, the difference may come from the age. So such an assignment is not a good assignment. And similarly, if we choose the second and third patient as treatment group, they are tall people. So such an assignment is not good either. So the division is an important step, and Nikolai et al. Formulated such problem as balance optimization subset selection. And it is a kind of sum of ratio optimization problem with binary variables. So more details of this problem will be given later. But this problem is shown to be an NP-hard problem. And usually it demands a long computation time. So in this talk, we'd like to propose a numerical method that combines three methods. So quantum annealing and alternating direction method of multipliers, shortly ADMM, and Dinkelbacher's algorithm. Okay, so to handle the binary variables, we use quantum annealing. To decompose the sum, ADMM is employed. And Dinkelbacher's algorithm is the numerical method to find the solution of this ratio. Okay. Here is the agenda of today's talk. So first, we'd like to start from more details of this problem. And next, we briefly introduce quantum annealing. And in quantum annealing, the problems must be formulated as cube model. So we also explain this cube model. And then we discuss the proposed method. In particular, we focus how to find the cube model in this optimization problem. And finally, we'd like to report some preliminary numerical results. Okay. So in experimental design, A/B testing can be considered as an important part. And A/B testing is widely used in many applications. For example, in medicine, Kertz et al. Used A/B testing to determine the impact of age and obesity after surgery. And recently, during the pandemic, due to the COVID-19, A/B testing was used to understand the effectiveness of this medicine. And as for websites, LinkedIn utilizes A/B testing to check the effectiveness of a new feature in the website. And we can also find many applications in other fields. So in experimental design, an important goal is to find a good split of the samples into the two groups. And today we'd like to focus this both problem. And a good split can be found by minimizing this chi-square. Okay, and this is based on chi-square fitness. And so we'd like to minimize this sum of ratios. Okay, here, C is a set of covariates, for example, age, height, and weight. And BC is a set of beans for covariate. So if C is the height, then the beans for the height is like these intervals. Okay. And in the numerator, we have TBC and DBC. And TBC is the number of samples in the treatment group. And DBC is that in control group. So simply speaking, this difference should be minimized. So for example, in this assignment, so we choose the second patient to the treatment group. And now we consider the height as covariate, and we focus the fourth being, so the interval between 170 and 190. Then in the treatment group, we have one patient. And in the control group, we also have only one patient. So the difference between the treatment and control is 0. So this assignment is good for the fourth being. But for the third being, the treatment group has no patient, but the control group has 2 patients. So for the third being, this assignment is not so good. Okay, so in addition to this numerator, we also have this denominator to compute the chi-square fitness. Okay, so the main goal of this talk is to minimize this function by using quantum computing. So we'd like to minimize this function, but here we have, we need to take marks of DBC and 1, but this part is difficult to handle in quantum annealing. So we slightly modify this denominator by DBC plus 1. And this function can be expressed as a quadratic function as the numerator and the linear function as a denominator. So now we prepare a new decision variable xi for I sample. For example, this xi can take a value of 1 if sample I is assigned to the treatment group. So here we have small example. So now we have 4 samples. So we also have 4 binary variables from x1 to x4. And we have 3 beans. And in particular, in the first bean, x2 and x4 are involved. So in this simple example, we can directly write down this I bar chi square. So actually, here is TBC. So the number of the samples assigned to the treatment group. So the number of samples in the bean 1 is 2. So the number of samples assigned to control is 2 minus x2 plus x4. So by introducing binary vector x here, then this part can be expressed in this way. So this part is x transpose, and this one is matrix Q1, and this is vector x. So the numerator is a quadratic function, and the denominator is a linear function. So the target problem is this one, and the decision variable vector x must be a binary vector. And mathematically speaking, this problem can be converted into the following mixed integer second order programming. So shortly, MISOCP. So the derivation of MISOCP is not today's main topic, so we don't discuss the details. But the point here is that if we use the branch and bound method, we can exactly solve this problem. For example, some commercial servers like Shiplex, Groovy, and Mosaic can directly handle this problem. So by using these packages, we can obtain the exact solution. But the computation cost is very high, so the available size is limited to at most 70. Okay, let's move to the next part. Okay, here is a part of the quantum computing. In particular, we are interested in quantum annealing. So simply speaking, quantum annealing is a quantum version of simulated annealing. So in the early iterations, the temperature is high. So usually the energy is also high and the structure is unstable. But in the later iterations, the temperature becomes low. So we have more stable structure and we can find a minimum energy in simulated annealing. So in quantum annealing, this procedure happens in a quantum level. And each qubit corresponds to a spin. So in this right figure, the red arrows mean the upward spins, and blue arrows are downward spins. So we can interpret these spins as binary variables. Of course, accessing spins usually requires difficult technologies, but recently, the company D-Wave can provide a real machine for quantum annealing. For example, D-Wave 2000Q uses 2000 qubits. And in addition, if we use this cloud service, then we can access quantum annealing 1 minute each month free of charge. So this 1 minute sounds very short, but each execution of quantum annealing is very short. So we can execute about 4,000 times. And in addition to D-Wave, other companies are also developing imaging machines. But D-Wave is actual quantum computer, but these imaging machines are based on classical computers. But the common point of D-Wave and imaging machines is that they are designed to solve imaging model or equivalently Q model. So in the next slide, we'd like to focus this cube model. Okay, so cube model is a very simple model. So the objective function is a quadratic function, and the decision variable must be a binary vector. So this model looks very simple, but solving QUBO is as powerful as quantum gate model. So most computations that we can use quantum computing can be formulated in this format. And recently, many researchers are trying to develop practical methods to use this cube model. So many combinatorial optimizations can be formulated into this format, in this model. And Volkswagen used cube model and D-Wave to reduce load congestions in the base density. However, the difficulty of cube model is it's very restrictive formulations. So we cannot use any continuous variables, and we have no constraints. Yes, so in quantum annealing, how to find the cube model is a very important step. Okay. So in this talk, we'd like to solve this both problem using quantum annealing. So here, the decision variable is a binary vector. So this is good, but the function is not a quadratic function. So we have to decompose this part, and we use ADMM as an outer loop, and Dinkelbach's algorithm as inner loop. So the most inside part is quantum annealing. Okay. And ADMM is actively studied in machine learning, and it can solve a consensus problem, like the sum of functions. So here it's also the sum of functions. So we can use the framework of ADMM. And to use this framework, we first duplicate decision variable vector x as x1 to xm. And we replace this x with xk. Instead, we add a new constraint, x must be equal to xk. So this problem is equivalent to this problem. Okay. And now we'd like to consider augmented Lagrangian function with multiplier of yk. So here we have the Lagrangian term, and we have our augmented term. And this rho is a constant parameter. So if this rho is sufficiently large, and we minimize this function, then this part is a squared norm. So this part should be 0. So we can recover x is equal to xk at the optimal solution. So instead of solving this problem, we can minimize this function. So we are going to minimize this function. And if we fix our original vector x and multiply it by k, then we can decompose this function into each k. Okay, so this part is denoted as function lkxk. So we minimize this objective function changing variables. Okay. So in the outer loop, the first step, we minimize this function with respect to each xk. And next, we fix this x1 to xm and multipliers, and we minimize augmented Lagrangian with respect to only x. And this is done by this update formula. And in a similar way, we also update multipliers. And this is done by this update formula. So we repeat this procedure until we obtain some convergence. Okay. So in step 2 and step 3, the computations are very simple linear algebras. But in step 1, we have to minimize LKXK. In particular, the first term is a ratio. So we have to consider how to minimize this function. For the ratio minimization, Dinkelbach's algorithm is a well-known algorithm. So now we try to minimize fx over gx. Dinkelbach's algorithm is an iterative method. So we start from some lambda, and instead of minimizing this ratio, we consider fx minus lambda times gx. Okay, and we use x star to denote the optimal solution of this one, and zeta as its optimal value. And in Dinkelbach's algorithm, if zeta is 0, then x star is the optimal solution of this problem, but also it is also the optimal solution of this problem. So if zeta is 0, we can stop the algorithm and output x star as the final solution. Okay. Otherwise, we update lambda by this formula. So if we consider Dinkelbach's algorithm as in a loop, then we have to solve this subproblem. Okay. So in step 1 of ADMM, we needed to minimize this problem. So we'd like to minimize this function. So now here is a numerator, and here is the denominator. Okay, so in Dinkelbach's algorithm, we have to minimize numerator minus lambda times denominator. So here is numerator and lambda and denominator. So we'd like to minimize this function. But when we focus this part, here we have the quadratic term, and here is linear term. So this term is a cubic term with respect to xk. So we cannot apply the quantum annealing if we use this expression. But here we need to consider only binary vectors. So for example, squared norm of xk is a summation of squared elements, and each element is 0 or 1. So this square can be removed. So this quadratic term can be expressed as linear term. So by applying the similar procedure, this function can be expressed as a quadratic function with respect to xk. So this problem is a cube model. Okay, so here is a summary of the proposed method. So the outer loop is ADMM. So in ADMM, we have to minimize this ratio. And for the ratio, we use Dinkelbach's algorithm. And to consider this minimization, we apply quantum annealing. Okay, so this is the part of the quantum computing. Okay, let's move to the part of numerical results. And in the numerical experiment, we compared 5 methods. The first one is ES, so exhaustive search. So we enumerate all the solutions, and we find the minimum value. And the second one is GR. So this one formulates the problem as MISOCP, and we use Groby to solve this MISOCP. And SA both is a direct application of simulated annealing to the both problem. And SAPM is a proposed method with simulated annealing for the cube part. And DW is a proposed method with D-Wave 2000X. So for the computing environments, except the quantum part, we use Core i5. And for the quantum part, we use D-Wave leaf service. And QPU time reported in D-Wave leaf includes QPU access time and QPU overhead. So we report these times separately. And as for the test instances, we generated them following the procedures of this paper, and we changed the size of problems. Okay. And this table shows the results of the proposed method with D-Wave. So the first column is the number of binary variables, and second column is the ranking of the output solution. So for example, here we have 340 over 32,768. So this means that the output solution is the 34th best solution among all feasible solutions. So when we focus this part, we often obtain the top 5 solutions among all feasible solutions. So our method can obtain favorable solutions. However, when we focus the computation time, this QPU overhead is relatively large. This is mainly because this part includes network connection. So the last column shows the computation time that excludes this QPU overhead. So when we focus the size of 15, so here, the computation time is very large. So in particular, long computation time, in the long computation time, we needed to execute many simulated annealing because D-Wave sometimes failed to some iterations. So in such iterations, we used simulated annealing instead. Okay. And in this table, we compare 5 methods. So for small problems, exhaustive search and Groby are very fast. But for large problems, they cannot complete the computations in 3 hours. Okay. And when we focus the objective value, simulated annealing to the direct application of simulated annealing is slightly better than the proposed method. But for the large problems, the proposed method is faster than the direct application. And the last 2 columns show the number of iterations in ADMM and Dinkelbacher's algorithm. So we noticed that D-Wave requires more iterations than simulated annealing. So in the next slide, we'd like to focus this point. Okay. So in Dinkelbacher's algorithm, we minimize this function, and if the optimal value is 0, we can stop the algorithm. And so the left figure is instance 2, so a smaller problem, and instance 3 is a larger problem. So in smaller problems, D-Wave can obtain a good solution. So the convergence in these 3 methods are almost same. But for the large problem, D-Wave requires more iterations like this. So we need 14 iterations for this part. And this is mainly because the solution accuracy of D-Wave is not as good as simulated annealing. Okay, finally, let me conclude this talk. So in this talk, we consider both problems, and we propose a numerical method using ADMM, Dinkelbacher's algorithm, and quantum annealing. And D-Wave can output top 5% solutions. And for large problem, simulated annealing with the proposed method is faster than the direct application of simulated annealing. However, D-Wave requires more iterations, and QPU overhead on the current machine is relatively large. And as future directions, to solve larger instances, we should divide such instances to sub-problems, and to improve, to reduce the number of ADMM iterations, we should combine some techniques, and to reduce the computation time, we should exploit more structures in the matrix. Okay, that's the end of my talk. Thank you very much for your attention.
Okay, thank you very much for the lecture and also for bahasa in your last slide, Professor Yamashita. That was interesting topic on how we implement the combination of 3 different methods to BOSF problem. And yeah, we can also know the application in real life problem. Okay. Okay, so let us give applause, virtual applause for Professor Yamashita. Okay.
Thank you very much.
Yeah, thank you very much for your lecture. Okay, let's move on to the last keynote speakers. Professor Isa. Okay, please have your time and please, prepare your slide first.
Okay, thank you for it's not yet business.
Not yet.
Can you see my?
Okay.
Okay. Yeah. Thank you for the time. I got a little bit different with two former thought. Two former thought about how computing, quantum computing for small problem. Actually, we start to learn what is the quantum computing itself. So I start with learn trend from my review in some source, and then I will conclude from this results. And then yeah, it's very interesting to learn quantum computing. Maybe I have to learn more about this. Yeah, this my presentation is review about the historical trend of machine learning research. Yeah, because my expertise in this field across two biggest platform of learning and computation in analyzing and modeling data. Yeah, this is the Kaggle.com, and we analyze the historical of method frequently used in machine learning to predict, classify, categorize, and explore dataset. In addition, we also analyze the use of the most effective tool and framework that are widely used for other sources, namely publication in indexed journal limited to ScienceDirect. Yeah, the two steps that we take as follow. First, the analysis is carried out on the discussion forum data for the last 10 years based on the data available in Kaggle. And second, look at the future trend of machine learning model, and we analyze the abstract of the article available on Elsevier search page and extract information from them using machine learning, and we utilize the result for extracting information from those two sources above to gain popularity and research trend that describe quantum computing. Yeah. What is machine learning? Machine learning is method of data analysis that automates analytical model building. Yeah. It's branch of artificial intelligence based on the idea that system can learn from data, identify pattern, and make decisions with minimal human intervention. Yeah. The issue of in machine learning, if we have purpose for to solve some problem, we have to prepare data according to the purpose, and we have choose a suitable machine learning that fit with the problem that we have to solve. And then the result of the solving by this machine learning, we check the performance. Usually the performance is accuracy and cost of computation. This is some of machine learning that usually used for some application. For example, for supervised learning, access classification and regression application. For unsupervised learning, usually for clustering, and reinforcement learning, usually for also for learning, but continuously learning. Yeah. Yeah, the material and method that I use for this small research from Kaggle.com, I use 264,496 data rows with 8 columns. Each column is ID, forum topic, and other medal awarded. As we know that this platform used for computation for computing for people who to take or to find the good idea to solve the problem. And then I only take the data from sciencedirect.com, to know how trend of machine learning and quantum computing that we obtained from 23,852 metadata with the keyword of this is machine learning, deep learning, quantum computing. Yeah. And we use the text analysis using text analytic toolbox. Yeah. First, we mix pre-process for the data. This is this usual for text analysis. Change the document to all lowercase and tokenize and remove all punctuation mark. And then eliminate conjunction and remove words that are too short and remove words larger than 20 characters and detect part of the document to update token in all detail using this function. For example, you are become you and I and one now. This become 1 and 2. But this only example. Actually, in the article in journal, this word is not exist. Oh yeah, but in Kaggle it's possible to find this. Yeah, word cloud as general. The step to create word cloud as follows. First, get a collection of text or word that express them in a variable and count the number for occurrence for each word and draw the text horizontally or vertically with the font size, representing the number of occurrence of the word in the document. And make sure the image of the text will not overlap this other. Yeah, this usually this function, and to use to know the trend analysis, we use the correlation formulas, and exists 7 7 types of correlation. In this case, I use a linear approach for this. Yeah. Yeah. Machine learning trend on Kaggle. Yeah, we use this for data analysis in this paper. Yes, I have already explained. The data were analyzed in Python and the program code and the data used to produce image presenting in discussion section can be obtained in Kaggle. Sorry. Yeah. Yeah, from my analysis using the use of data. Yeah, this is the based on this figure, we can see that in 2018 to 2020, the kernel became dominant after it was launching in 2016. Yeah. And then after 2020, number of dataset become largest and far more than when we compare to the other 3 types of media. Yeah, the increased dataset is allegedly due to the explosion of COVID-19 cases around the world. Yeah. The case that I found from the data, the machine learning, the application of machine learning, in this case, yeah, since since 2012 until recently, the case is prediction and classification. Yeah. And usually use linear regression and logistic regression. And the domination of XGBoost and prior to 2015, linear model, decision tree, and random forest were very popular. But when XGBoost open source in code in 2015, the XGBoost gained popularity quickly and dominated the competition and the kernel on the Kaggle. At this time, XGBoost is still being used and is part of the most used model by the competition winner. And then trend of neural network and deep learning. Deep learning is also becoming popular every month as different model variants, such as recurrent neural network, convolution neural network, have shown major improvement to the kernel. Also, the linear transfer function and the pre-trained network model have shown good result in the competition. Yeah, the use of framework in machine learning with the popularity of Python for machine learning. Yes, skitlearn was before 19 people use machine learning, but since 2015, TensorFlow has become increasingly popular among the machine learning tool, and also Keras is the most popular because of its simple deep learning implementation. Starting in 2020, PyTorch began to dominate, which it was then followed by TensorFlow, along with the release of the TensorFlow 2, which is getting easier to use. And if we compare between the XGBoost and deep learning using Keras, in the beginning until 2018, XGBoost is dominant, but after 2018 until recent, the Keras is start to dominate against XGBoost. Then the most popular of deep learning that appear in the research that published this convolution neural network and long short-term memory has the same popularity. And what do Kaggle use for data visualization? Usually for visualization using Matplot or Seaborn or Plotly. This three library is used for popular use for this. So sorry, this in Indonesia. A number of papers that discuss machine learning in Python library exists. Linear regression is much paper that discuss this, and logistic regression is also, and decision tree, random forest, and also this is the paper that use Python library, but other paper not use this Python library. Maybe they use or make program by themselves. And the trend of machine learning in ScienceDirect, from this we explore what is the trend of this the research in this area. We use abstract inference, and then the number of article, this since 2020, the number of article that contains apply machine learning is has great increasing. And if I process the data using a small program, and then I perform a workload for this abstract. The 5 most discussed about the syllabus in the abstract is about learn, ratu, model, method, and purpose. Yeah, this is not very clear what this means, but if I use two words, workload with 2 words, I found neural network, deep learning, machine learning, and convolutional neural. Yeah, this is the trend of machine learning. And then the word that connected with machine, if I draw the web, this machine algorithm, classic machine technique, artificial machine, and support. And if I connect word connected with learning, my purpose to use this to find what is there any connecting between learning with quantum. I searched this. I didn't find it. I try to use another keyword with application. Application, machine. Okay, this is the word that connected to application. I'm still fine to get the word of computing as a quantum or quantum computing or quantum learning. Then if I use keyword trend, I got some trend of time series, seasonal, this economics. This trend is usually used in forecasting. Then we will analyze machine learning trend based on the frequency of mention of the topic content the abstract data. If I compare supervised, unsupervised, and reinforcement, the supervised is get the higher user or report in article of the journal. The enforcement is number 2, unsupervised is below the reinforcement. And then by calculating the frequency of occurrence of words related to the purpose of using machine learning in all abstract data, if we compare this with 4 words, we found that classification is the most popular in the article in scientific, and then followed by regression and clustering, and then reduction. Yeah, then after I try to find using this method, okay, what is quantum computing? This is computation that focus on the development of technology based on quantum theory. The quantum theory is based on the possibility that every event can occur, even it looks impossible. Computer usually, conventional computer that we have recently, usually only write code information in bits by talking the value 1 or 0. In other words, it's binary. Yeah, like what the former speaker told to us. In quantum computing, there are so-called bits and qubits. And quantum computer use qubit, which are arguably subatomic particles such as electron and photon. The point is, with quantum computing, what was once only between 1 or 0 can now be more than one state, such as 1 and 0 at the same time. Yeah, this is the advantage of quantum computer, that not only check one between 1 and 0, but the quantum computing can use 1 and 0 at the same time. So the quantum computer can process any request more quickly and effectively than normal computer. Yeah, and we tracked the use of the word of machine learning, deep learning, and quantum learning in the abstract dataset. The appearance of quantum learning since in the article at 2017, and then yes, this number of words, yeah, not number of article, and then in 2018, more than 1,000 words. Yeah, until recently is more than 7,000 words. Yeah, and then from this analysis, the data that we found from the abstract, recently is access about 160 articles that contain quantum computing. And then the trend maybe from this year, this research about quantum computing is a very emerging area. This is more possibility for mathematicians to explore and research about this quantum computing, because this quantum computing is the word of quantum, it means this related to the science, to our department, that is physics, science physics. So our responsibility to develop this field area in order to make our department or our faculty can compete with other faculty in support the development of technology. Yeah, so this the percentage of quantum learning is relatively small. This machine learning, the general machine learning, and this is the deep learning, and this method get popularity recently. Yeah, and what connected to the quantum? Yeah, if I put the keyword quantum, it's correlated to qubit and Hamiltonian, some other this theory, logic, momentum. Yeah. This is the photonic. Yeah, this the word that related to the quantum term. Yeah. And if I put the two words, the three words, words that are connected with the word quantum, still dominated by terms that describe method, meaning that quantum computing currently is still not widely applied. Yeah, like quantum anomaly that explained by my former presenter. Yeah. So this little talk about the trend of this quantum computing, the trend of quantum computing that I found in the some source, not all source, because it's not enough time to analyze from other source. Yeah. The conclusion is based on the trend analysis result from two sources, the ICoMPAC and SciDirectCom. At least it's possible to obtain an overview of the development and trend of machine learning and its role in data science. Furthermore, the discussion about quantum computing as a better future of computing, that quantum computing is currently still not widely applied, but quantitatively has a significant increase in articles published in SciDirect. Yeah, this is the I think this all my presentation. I return the time to the moderator.
Okay, thank you very much for Professor Issa. So we learned a tool, to know a trend in machine learning and also a quantum computing. Okay, so now we have listened to all lectures. So I will open a question and answer session. So we have 30 minutes, I think, for question and answer. So please raise your hand if you have any questions related to the lecture. I think that Professor Subiono.
Okay.
It's
time for me?
Yes, please.
Okay. Thank you very much, moderator. I have one question for the first presenter. Really, I do not understand much of what you presented in this morning. Please explain what is the real main problem from classical computing to computing to quantum computing, and what is the meaning of computational stability due to operator error. In this case, is quantum computing more stable than classical computing? It's all. Thank you.
Okay, thank you very much for the question. So please, Professor Jamin.
Okay, thank you for the questions. Actually, quantum computer is much less stable than classical computing. And that's one of the biggest problems. Classically now the processors we have now, the modern processors, Intel, AMD, ARM, Apple, Silicon, they are very, very reliable. They have one error every 10 to 7 or 10 to 17 now, I cannot remember, but the processor make one error for every very large number of computations. So they are extremely stable. You can put them in room temperature. You can operate them in a very, well, depending on the computer, of course, some of them can operate on a high temperature. Some of them can operate on a very cold temperature. So essentially they're very stable. You bring your laptop around to a cold place, to a hot place, it still runs nicely. For quantum error correction now, we don't even have a processor which is large enough to implement quantum error correction. So the one that IBM has, that Google have. So I'm of course talking about the processor, the quantum processor that have been announced openly. You know, we don't know if there's some secret laboratory somewhere with more advanced design. So doing error operations in classical setup is usually done for data in transfer. When you send them across communication channels, whether it's wired, wireless, via satellite, then you need to do error correction there. But inside the computer itself, inside the processor, you don't need to do a lot of error correction because the processors themselves, they're already super stable. They are super reliable, no issue performing computing there. Now, when you look at the design of quantum processor, the one that we have right now, the processors themselves are not stable at all. So if you look at the theoretical foundation of it, the theoretical foundation says there is a method to keep error to a level that is acceptable so we can perform quantum computation. The problem is keeping error in that acceptable range is very difficult to engineer at the moment, very difficult to engineer. What we know as quantum stabilizer code is perhaps the best model we have, or the best known model we have to stabilize quantum processor. So to start answering your question specifically, in the classical setup, we don't have problem with the reliability of the processor themselves, the computer themselves, by and large. In the quantum setup, we have big problem because the processors themselves are not reliable. In fact, engineering-wise, we don't have large enough scale known quantum computer that can already perform error correction. So the theory is already up high there, but the engineering is still very, very low. So what we as a mathematician who are working in quantum error correction can do is to prepare a system that says, if you want, let me see. Let me go directly to the web page. Okay, it says if you want to stabilize, all right, so here it is. If you want to stabilize quantum code, we provide a system on how to design the error control mechanism. So for example, here, this essentially says you have a quantum computer of length, a quantum computer that operates on 17 qubits, physical qubits, but it actually only executes 3 logical qubits. And here you can perform error correction up to 2 arbitrary positions. So out of 17 positions, you want to be able to correct in 2 arbitrary positions. The set of error that you can correct is the set of error operator, which is generated by this form. So this is the expression of error operator in terms of binary factors. Again, so if you look at it, the first part here is 1, the second part here is 0, this is sigma x. So what we are doing right now is still very, very, very basic. What we are doing is, if you want to build a processor that has this capability, the processor can handle 3 qubits of logical information and code it into 17 qubit of physical information, okay, of physical form. So the information is just 3 qubit. They're embedded into 17 qubit of physical qubit. Okay, so 3 logical qubit in 17 physical qubit, and you want to be able to correct errors that happen in any arbitrary 2 of them. Then you use this design. You design your error control mechanism in the following way. Okay, so this is still very, very basic. What happened is, for example, Google says, for example, okay, they have a processor, a quantum processor that can handle 100 qubit. This is 100 physical qubit. How many logical qubit? Well, depending on the design of the gates, because not all of the qubit can be done to perform information processing. Why? Well, you need an operating system to begin with. You need some memory allocation. You need the usual computer architecture to implement. And that's why I said that at the moment, we don't have any quantum processor which is large enough to even perform basic quantum error correction. Okay, so what value does the classical coding community bring to the design of quantum processor? We bring a wealth of understanding on the classical code that says this is how you can control the set of error operator. You control the set of error operator based on what we know classically, and from there we say you need to design a code that is capable of handling this kind of error. Okay, this is how you design it. So if you click this Grassel table and you see this one, this is actually the stabilizer matrix is a signal to the physicist that says, guys, please look at all the error operators here, and the set of error operators there are actually the basis that generate all the error operator, the group of all error operators that you can handle. So it depends on your need. If you need something which falls into already in this list, okay, then just pick one of them and you can perform it. Okay, so now, but again, if we go back to the lecture and I say that in classical coding theory, what we consider to be good code may not be necessarily good for quantum setup. Because first we need to consider codes which are self-orthogonal with respect to the trace Hermitian inner product or to the symplectic inner product. And these two, of course, are not the usual inner product we use in the classical setup, because in the classical setup, we use the normal Euclidean inner product most of the time, like say 99% of the time, that's the inner product that we use. So the problem in quantum setup, when you translate it to classical setup, becomes a problem which classical coding theories don't usually consider. But we have all the tools. So what happened is we use the tools to now handle this kind of problem and then send it back to the physics community and say, well, this is the result that we get, analyzing it from the classical code. So this quantum stabilizer, you can think of it like a bridge that translates problems in the quantum setup to the classical setup so that classical coding theories can help. And then it can get ported back into the quantum setup and say, well, this is how you design it. Is this stabilizer mechanism the only error correcting codes we have? No, but this is by far the simplest to explain and the simplest to implement. So there are others which are more complicated, but in the end, typically for engineering problems, right? The engineers would like to have something simple and clean, easy to implement, maybe not optimal, but easy to implement, and then modular. Modular in the sense, we deal with qubit here by block. So if I have 100 qubit, can I split it into 4 block of 25 and I handle it by block? So something like that. We want it to be modular, we want it to be simple, and the stabilizer formalism is the simplest we have at the moment. So I hope that sort of explained a little bit of where we are right now.
Okay, thank you.
Welcome.
Okay, thank you very much for the question and also for the answer from Dr. Ezerman. Is there any question for Dr. Ezerman before we move on to other question? Okay. First, let me ask a question. Okay. So I'm interested in your code tables. Hello. Okay, so since this topic is out of my field, so I would like to know, so this code table shows the bonds, the bonds of the code. So what's the difference? I see. So I would like to ask, what's the difference between the range and
Okay, so let me pick something which has some gap. Let me see here. Okay, so what is the difference between a lower bound and an upper bound? The lower bound essentially says we know exactly how to construct the code. So the code given here is designed classically by a cyclic code. Well, cyclic code, I don't want to explain it now. Generated by this polynomial. So we know how to generate this classically, and we know how to generate the basis. Okay, when you express this in terms of stabilizer matrix, it will be like this. It becomes like this. So the stabilizer matrix is actually the common language that most classical coding theories and our colleagues in physics who are implementing error control, this is a common language. We understand this. So for the physicists, when they look at the stabilizer matrix, they just look at the first component of the first row. Okay, so this is 1 and this is 0. So here it can handle sigma x. Okay, and if I look at, let's say this one, this is 1 and that is 0. Okay, I want to look at something else. Okay, so 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so here, this is 1 and this is 1. So here you can have composition error, sigma y error. For people in the classical setup, we know that, well, this is a matrix. This factor, so this explain a code. The whole thing is a code. Okay, this is a code, a binary code. So that means over F2, the length is 2n. N is 24 at the moment. And so this is a common language we understand, back and forth. Now what happened with the lower bound? Lower bound means this code, if you look at this code is self-orthogonal with respect to the symplectic inner product. And the minimum distance of this code, is 5. If you look at it in terms of quaternary code. So when you express this code as codes of length n over F4, okay, so how do you, so you fold the code by saying, okay, I look at the first element here and the first element here and say, in F4, that is 1. Okay, and if I take this one right here and this one, so that represents an element which is omega in F4. So if I write it as an F4 code, the minimum distance, remember the minimum Hamming distance is the minimum weight of all the non-zero code words. It will be 5. However, it is also still possible to have minimum distance 6 and 7. It's just that we don't know how to construct them. We are also not sure if they exist. So when I say that the open problem, the research problem, therefore, will become, can you build something better than 5? Let's say you can build 6. And then if you can build 6, then of course your code becomes the new record holder and it will be put here. Or can you do some combinatorial analysis, linear programming analysis, or whatever it is, whatever tool you have, can you make this 7 lower? If you can make the 7 lower to 6, for example, then that is also a better code, in a sense that you narrow down the gap and therefore your result will be listed here. Okay? Actually, right now with Marcus Grassel and with Buket, we have several hundred new codes. This is that the search is still continuing and we haven't written the final paper yet. But soon we will update this with a lot more new codes. It takes a long time because computer search can be quite slow. But yes, there is still a lot of opportunity. So let's say this entries right here, the gap is very, very big. Here, failed construction means we don't have any record actually how to construct this. It's just that some people at some point claim there is such a code. So then we write a note there that we don't know how to construct this, can't find a record. So it's if any one of us can fill up this gap, and then wow, I think that's a publishable result. Thank you.
I see. Thank you. So I would like to confirm that if we have the value, I mean, if we have the same value of the lower bound and also the upper bound, so we only have one possibility. I mean,
yes, and this kind of code we call it optimal. Optimal, that means the best. That means we don't need to search for it anymore. We know how to make it.
I see. Okay, thank you very much. Okay.
Welcome.
Okay, thank you very much for Dr. Zaman. So now I will move on to other question from Dr. Subhan. So would you like to ask directly or?
Okay, thank you. Can you hear me, Dr. Sena? Okay then. Yes, actually, my question is little bit, I mean, because I don't have information about quantum computing, not really learning about quantum computing. While my area is little bit, I have optimization area. So as Professor Yamashita mentioned that he explained area research in the optimization for quantum computing.
Yes.
So, which optimization method appear the most emerging in the quantum computing?
In optimization field, so now many researchers are trying to use many optimization methods in the framework of quantum computing. But in quantum annealing, in today's talk, let me see. In today's talk, I used the augmented Lagrangian here. I think augmented Lagrangian is one of actively studied method that connects quantum annealing and optimization. In particular, here we add the Lagrangian part, and here is augmented part. So these parts are quadratic function. So in quantum annealing, we have to make the objective function as quadratic. So we can add these terms as quadratic terms to the objective function. So augmented Lagrangian is one of active numerical methods. And I think another important numerical method related to quantum annealing is a Boltzmann machine. So Boltzmann machine is a kind of neural network. So Boltzmann machine and how to say? So the fundamental aspect, theoretical aspects of Boltzmann machine is closely related to quantum mechanics. So I think using a Boltzmann machine will be a important step to develop quantum annealing or numerical methods that use quantum annealing. Is it okay?
Yes, thank you, Prof.
Thank you very much for your question.
You're welcome.
Okay, thank you very much for the question, also the answer. So again, before we move on to other questions, so let me ask some questions. So first, for DOSS problem, so is it possible if we add additional constraints? So for example, if I want to add linear constraints, so is that possible?
To apply the quantum annealing?
Yes.
Yes, let me see. Let me see. So in quantum annealing, so let me see which page. Yes, in cube formulation, the objective function must be always quadratic function. So if we'd like to add some linear constraints, can I write here? So if, for example, if we have, can I see this? Can you see this one?
Yes. Yeah.
So if we have the linear constraint like x is b, then instead of this one, we should add some parameter rho and x minus b squared. So instead of this one, we add this linear function as a quadratic penalty term.
I see. So we move the constraint to the objective function, objective function first, then solve by.
Yes. So So equality constraint can be formulated in this way, but inequality constraints are very hard. So this time, many researchers are proposing many methods to handle inequality constraints.
Okay. And for the second question, so in the ratio, so in the second page, I think.
Second page? Okay.
Yes.
Page 2?
Yeah, page 2.
Okay.
So for the ratio, for the objective function, so the numerator is a quadratic function, but the denominator is a linear function. If I exchange, so the denominator is a quadratic function and the numerator is a linear function. So is it possible to exchange the positions?
I think it's possible, but let me see. So yes, this part and this part will be exchanged. Yes. So yes. In this framework, we can exchange this part and this part. But numerically, I think it will be unstable. So the computing the accurate solution will be very hard.
It will be effective this algorithm. Okay. I see. Okay. Thank you very much for the answer.
Okay, thank you very much.
Okay. Thank you. So I think we will move on to the last question. So please, Dr. Dicky, if you want to directly ask Professor Isa. Hello.
Hello there, Dicky.
Okay, please, Dr. Dicky.
Yeah. Yeah. Okay, thank you, Bu Sena. Yeah. So in the presentation, you mentioned about there are some research about quantum learning. As far as I understand, it is a combination of quantum computing and machine learning. In graph, I think the amount is quite low now. I would like to know, what do you think the trend of quantum learning? Will it be a hot topic in the future, or maybe not? I don't know. What do you think? Thank you.
Okay, thank you, Mr. Diki, for the question. Yeah, according to my track to the document in Science Direct is the research on quantum. It is not much. Yeah, I found only 150 articles that talk about this quantum learning or quantum computing, but this area I think is depend on the development of the foundation of this quantum computing. If the foundation is developed very fast, and we can use this foundation to apply to machine learning, I think the quantum learning can increase. The research in quantum learning will increase not like this time. This I think this time is very low total of the research about this. But this is the obstacle also from according to Dr. Martianus, the theory is very high level, but the engineer who create the computer is not very high level for the achievement. I also ever know to see the quantum computer in YouTube. I search what is quantum computer. This computer is recently it's not like the compact computer that we have recently. This I think is like history of the PC in the beginning of the development of PC. When PC is very big, in like one room, just only one PC for 2 days. I think if the obstacle of the engineer to develop the quantum computer is can break the trend of quantum learning will increase also like the development of the hardware itself. I think this that I can answer from the question of Mr. Diki Atskia.
Okay, thank you, Professor, for the explanation.
Can I add a little bit?
Yes, please.
Yes.
Well, continuing on this answer, Professor Isairawan is spot on, right? The problem is when you do machine learning, what do you perform? You perform simulation. Where? On actual architecture, on actual neural network, on actual system. Problem is, how do you do simulations when you don't have the computer to do it? I mean, this is of course one big reason why we don't see a lot of work in this. I mean, with my colleagues and friends in Samsung Research Indonesia, I do a lot of machine learning on images, and of course we can do that classically because we have GPU, we have all this powerful thing. Now, if you want to do quantum machine learning, the first question you have is, okay, reality check, sanity check. How does this machine behave? You don't know. Do you have access to it? Well, unless you are one of very, very few people who have direct access to machines like that, then there's nothing you can do. So at the moment, this is still a lot of theoretical questions related to the complexity and the algorithm, but I don't see any chance of making big progress unless there is an engineering leap. We have access to some machine, we can do simple simulation, then maybe that's game on. But at this point, I think it's very, very hard. Yeah,
it's very hard. Okay, thank you.
Okay, thank you. Is there any additional comment? Okay. Is it enough, Dr. Diki?
Yes, thank you, Susanna.
Okay, thank you. So here there is additional comment in the chat from Dr. Ezerman, so you can read it. Okay, since we run out of time, so I will close this session. Again, thank you very much for all lecturers. So we we get new insight, new knowledge, and also now we know about the basic of quantum stabilizer and also how to implement the quantum computing for optimization problem, and also we know a tool to know the trend on quantum computing. Okay, so if you have other questions, so maybe you can directly ask to our keynote speakers. So I will, okay, so before I close this session, so let us applause for all keynote speakers. So please give applause virtually. Okay, thank you very much. So I will give the time to the MC. Okay, thank you.
Thank you, keynote speakers, for the wonderful presentation, and thank you, Dr. Safarina, for conducting this amazing session. Please once again give applause to our keynote speakers and moderator by using the Zoom reaction feature.
Moreover, we would like to present a certificate of appreciation to all of our keynote speakers today. And now, I would like to invite Dr. Subhan, PhD, as the head of Mathematics Department ITS, to give the memento. To Dr. Subhan, the time is yours.
Okay, thank you. Dear all speakers, I would like to say thank you for all keynote speakers for your interesting and enlightening presentation. We really appreciate that. I have a small token of our appreciation here for all of you. Please accept it with our sincere thanks. Thank you.
Thank you, Dr. Subhan. Ladies and gentlemen, we will now have our lunch break for 30 minutes, and we encourage you to remain in the Zoom meeting until the break is over at 12 p.m. GMT+7, so we can continue with our parallel sessions directly.
And also, regarding for the sessions, please join the breakout room for your respective classes right away at 12 p.m. GMT+7. Please note that we will be closing ICoMPAC 2021 after the parallel sessions. Thus, we expect you to come back to the main room after the parallel sessions have finished. Once again, good afternoon, and please enjoy your lunch break.
Thank you, everyone.
Thank you. Thank you, Prof. Zurman. Thank you, Prof. Yamasita, Prof. Iza.
Thank you. Thank you, everyone.
Oh, thank you very much.
Thank you. See you next time.
Thank you very much.
See you. See you.
Oh, thank you.
Thank you, Prof.
See you.
Sudah kelewatan. Tadi moderator juga nggak mempersilahkan. Iya. Persiapan paralel, Mas. Saya persiapan paralel. Nah, untuk ini lagi.
The world keeps evolving. The times keep changing. The new
Kalau video nih, kan? Iya. Iya. Gak ngerti, lalu ini sama jalan di videonya. Video matematika ITS. Oh, tes sesuai. Enggak. Kenapa? Speaker kereta. Gak jadi. Tadi itu yang situ nggak bisa share screen kan. Terus kayaknya saya dengarnya moderator nggak mempersilahkan ini si speakernya untuk menerima
MC memang.
Iya maksudku MC-nya ya.
MC enggak kan?
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957.
Recording stopped.
In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including scientists, INSIS, vocation, creatives, MarTech, electives, SIFPlan, interdisciplinary school. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With the spirit of heroism, ITS brings the future before us. ITS, advancing humanity.
Institute Technology 10 November Surabaya, as one of Indonesia's leading universities for study and research, is built above 180-hectare land, currently accommodating 18,484 active students, 1,094 lecturers, and managed by 1,561 staff members. Launching program Smart ICoCampus at 2011, ITS is fully equipped with integrated technology. Students can learn and interact through Smart Class program by simply log in at the designated time for an online class session. Massive open online courses, MOOCs, are free online courses available for anyone to enroll. All accessed by smart cards, application, web, and mobile site. Smart ICoCampus is also implemented by building an eco-farm to obtain environmental-based lifestyle. ITS is providing iCar, an electric self-driving car, with 20 stopping points utilized by iCar app. Campus Bike to simplify student mobility around campus. Supply with best facilities, students can live comfortably inside ITS campus. Starting from excellent student dormitories, canteen and cafeteria at various places, K1 Mart to shop daily needs, Manarul Ilmi Mosque, accessible toilets for disabled people in every area, various sports facilities, indoor and outdoor fields, a medical center as health service unit, language and culture center to boost English competence, ITS library, and several co-working spaces as a learning resource center. ITS provides more than 184 laboratories spread across 7 faculties. Among them are the Robotics Laboratory, that has pioneered research, development, and education, and already successfully winning national, regional, and international robot contests. Robotics team built Robot Medical Assistant, RAISA, to reduce the workload of medical personnel and minimize the exposure of viruses. The Energy and Environmental Laboratory was the main task to support ITS main research and provide consulting, analysis, and training services. Material and Energy Laboratory, equipped with the latest machinery to help students learning to determine product and material quality control. Architecture Laboratory provide places for students to design, produce, and refine their architectural artistic creations. Geomatics Laboratory is utilized for mapping survey to support the geospatial information industry and natural resources management. ITS Techno-Science as a place for ITS to contribute to the industry by collaborative learning to support technological innovation and commercialization, business creation and employment development, economic development, which all incorporated in Science Techno Park. High technology in line with natural environment makes ITS beautiful and comfortable, important to create a supportive learning atmosphere for the students.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including scientists, INSIS, vocation, creatives, MarTech, electives, Plan, interdisciplinary school. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With the spirit of heroism, ITS brings the future before us. ITS, advancing humanity.
Institute Technology 10 November Surabaya, as one of Indonesia's leading universities for study and research, is built above 180-hectare land, currently accommodating 18,484 active students, 1,094 lecturers, and managed by 1,561 staff members. Launching program Smart ICoCampus at 2011, ITS is fully equipped with integrated technology. Students can learn and interact through Smart Class program. I simply log in at the designated time for an online class session. Massive open online courses, MOOCs, are free online courses available for anyone to enroll. all accessed by smart cards, application, web, and mobile site. Smart Eco-Campus is also implemented by building an eco-farm to obtain environmental-based lifestyle. ITS is providing iCar, an electric self-driving car, with 20 stopping points utilized by iCar app. Campus Bike to simplify student mobility around campus. Supply with best facilities, students can live comfortably inside ITS campus. Starting from excellent student dormitories, canteen and cafeteria at various places, K1 Mart to shop daily needs, Manarul Ilmi Mosque, accessible toilets for disabled people in every area, various sports facilities, indoor and outdoor fields, a medical center as health service unit, language and culture center to boost English competence, ITS library, and several co-working spaces as a learning resource center. ITS provides more than 184 laboratories spread across 7 faculties. Among them are the Robotics Laboratory that has pioneered research, development, and education, and already successfully winning national, regional, and international robot contests. Robotics team built Robot Medical Assistant, RAISA, to reduce the workload of medical personnel and minimize the exposure of viruses. The Energy and Environmental Laboratory was the main task to support ITS main research and provide consulting, analysis, and training services. Material and Energy Laboratory, equipped with the latest machinery to help students learning to determine product and material quality control. Architecture Laboratory provide places for students to design, produce, and refine their architectural artistic creations. Geomatics Laboratory is utilized for mapping survey to support the geospatial information industry and natural resources management. ITS Techno-Science as a place for ITS to contribute to the industry by collaborative learning to support technological innovation and commercialization, business creation and employment development, economic development, which all incorporated in Science Techno Park. High technology in line with natural environment makes ITS beautiful and comfortable, important to create a supportive learning atmosphere for the students.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including scientists, INSIS, vocation, creatives, MarTech, electrics, Plan, interdisciplinary school. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space new generation.
Ya enggak Kak, berarti harusnya nggak ada bocor Kak. Jangan-jangan dari HP jenengan tadi buatan. Apa?
Bu Endah.
Sini yang bagian sertifikat Pak, zoomnya bermasalah. Jadi ketika mas screen ini freeze.
Nah sekarang yang untuk apa base paper atau base video dicoba dites. Kok malah muncul wajahku? Ngeri.
Enggak di Ini di Zoom. Tapi kalau di YouTube munculnya ini.
Salah kita videonya. Ini.
Nggak ada di sini juga nggak ada.
Itu Bu Enda sana. Duh. Tapi kok kau ini?
Coba sih, Bu Enda.
Iki Enda.
Anda sudah disconnect audio.
Disconnect audio kok Bu.
Mbak ampun Mbak. Mbak sana sekolah Mbak.
Mbak Mas Ali.
Rujak tadi. Rujak tadi Mbak.
Mas Ali. Wes Bu.
Ali.
Apa? HP-mu Mas, jangan-jangan Mas.
Aku nggak join apa-apa kok. Ini juga untuk
HP.
saya nggak join.
Memutar audio.
Enggak, ya masuk.
Mungkin bisa.
Saya nggak join.
Mati Mas. Sudah Pak Paul.
Suaranya dari UPS. Oke, bisa rekam. UPS mikrofonnya jalan. Kok UPS? Tadi yang suaranya bilang itu masuk ini. Suaranya.
ICoMPAC. Kita nyala nol.
Enggak Mas. Kalau misalkan dia bunyi, itu tadi pasti sudah ada yang protes. Karena Pak siapa? Biasa Pak Hadi kan ini YouTube, pasti ini protes di sini. Gak mungkin. Wong suaranya Bu Sena cening-cening WA itu teko Pak Hadi.
Pak Hadi
Pak Hadi Santoso.
Melo Pak Hadi.
Iya di YouTube lihat. Bu Hani itu centang-centing YouTube iki WA Bu Sena. Iya. Centang-centing WA dengar di YouTube. Lah saya makanya tak bilang tak delok sapa iki ya sing nyala mikrofon cuma dia. Lah iki Bu Sena. Ya kita kan dikai tahu Bu Enda kan.
Cuma ini aja.
Balik lagi ke video. Jam kita mulai lagi jam 12 ya?
Sudah jam 12.
Sudah masuk kan ke enggak, saya nyoba ini masuk ke salah satu room, baru nanti saya masukkan di mungkin room A saya ikut 2 presentasi, room B 2 presentasi biar enggak nganggur.
Solehan direk.
Oke, foto lagi nih. Siapa yang spot lagi?
Soalnya aku rumah buku iki.
Enggak usah Pak, nanti pakai yang scene ini aja, scene video. Jadi orangnya share screen mukanya kan nampak, ininya juga nampak share screen.
Sudah jadi nang Pak ininya sertifikatnya.
Enggak, bukan itu. Nanti Bu Hani kan ngirim siapa yang kasih ke keynote speaker itu. Apa sih
Bu Sena. Salah kok di rumah Bu. Bu Sena itu ya sih.
Bu Sena.
Bu Sena. Salah. Mas buat mata ini kan Mas. Mata ini Mas mikrofonnya Mas. Kok mau buka
Good afternoon, ladies and gentlemen. As the lunch break have finished, I would like to remind all participants to join their respective breakout room right away as the breakout room has been opened. Thank you very much.
if the sigma is in the form of couple 2, 1, 2, 3, 4, and so on, the sigma of C is also the Gikisi codes, but the special form of the sigma bar is shown in the screen. Same with the second corollary. The third corollary is telling us about if the sigma is in the form of couple of 3, 1, 2, 3, 4, 5, 6, and so on. This is the special form that we can use to get the sigma bar. I'm sorry, this is actually the first corollary. It is the generalization of the second and third corollary, but it is in a more abstract form, 1, 2, 3 until S, and so on. This is the special form that we can use to count the new sigma bar. This is the example of the mapping of the code of C. If we given C like that, when the Q is 3 and the length of 3, and sigma is 1 to 3 to 2. And this gray map that use is alpha plus beta V is mapping to alpha, beta, alpha plus beta. This is the result, and this is the new sigma, such we call sigma bar, 1, 2, 4, and so on. After we get the theory, we try to automatically search the code using computation. This is the general algorithm that we try to generate. This is the general step. And after that, we get that the time complexity of it in the big O notation is O n cubes plus P with the power of K, where n is the length of the codes, K is the dimension of the codes, and P is the size of FP. Here's the sum of the table that include the sum of the codes that we try to search. This is the codes over F2, over F3, over F5, over F7, over F11, and that's it. All right, that's all. Thank you for your attention. If you have any question, please contact me. And this is some of the reference that I use. Thanks for all the author. All right. Thank you. See you next time.
Okay, thank you for the presentation. This is the time for the question and answer. For the video number 3, is there any question? No? Mrs. Sunarsini? No. Okay. Okay, like my question before, I want to ask for Muhammad Irfan, why you choose the gray map? Since I read about your papers, you also construct about the cyclic code, yeah, QIC, but not using gray map. And what is the benefit maybe, or the something that motivates you to use the gray map? Okay, thank you.
All right, thank you for the question. The reason I use the gray map is because in 2019, Dr. Irwansyah already do the research about gray map and using other codes, and it's produce optimal code. So I try to do it with generalized quasi-cyclic to try if it produce optimal code also. So in the result, it show that we could produce an optimal code using gray map. Okay, thank you.
Okay, so it's extended from the previous paper, right? But the object is different. Okay.
Yes, miss.
Yes, thank you for the nice presentation. Please give applause to presenter number 3. Okay, we continue with the video for number 4. Are you ready, Dramasta?
Yes. Actually, before continuing, I would like everyone, both presenter and participant, to fill in the link for the attendance. I have sent the link for the attendance for both participants and presenter in the chat box. So while watching the presentation, I would like all of you to fill the attendance. Okay, so next we shall continue to the 4th presentation from Institut Teknologi Bandung with the paper title of Structural Properties of Skew Cyclic Codes over a Finite Ring.
Greetings everyone. Today I'm going to present our work about the structural properties of skew cyclic codes over a finite ring. Cyclic codes were first studied by Prince in 1957. In 2007, Buche, Gisselman, and Ulme defined skew cyclic codes as a generalization of cyclic codes. In 2014, Buche and Ulme studied skew cyclic codes with derivations over finite fields. Recently, in 2018, Sharma and Bainwal studied skew cyclic codes with derivation over the finite ring Z4 plus UZ4 with U square equals 1. In our work, we investigate the structural properties of skew cyclic codes with a derivation over the ring Z4 plus VZ4 with V square equals 3. First, I will explain some basic notations and definitions. Let R be the ring Z4 plus VZ4. This ring contains numbers in the form A plus B phi, A, B, and Z4. It is isomorphic to Z4 phi modulo phi square minus phi. The addition and multiplication in R are similar to the complex numbers and the Gaussian integers, but the term B div phi square is converted to B div times phi. An element A plus B phi in R is a unit if and only if both A and A plus B are units in Z4. Therefore, R has exactly 4 units, 1, 3, 1 plus 2 phi, 3 plus 2 phi. Now we can define codes over R. A code over R is just a non-empty subset of Rn. We call it linear if it is an R submodule of Rn. We call it free if it is also a free module. A free module is a module with a basis. Next, let us see about the skew polynomial ring Rx theta delta theta. Here, theta is an automorphism and delta theta is a derivation. What is a derivation? If we have an automorphism theta on a finite ring R, we call a map delta theta a derivation on R if it satisfies the additive property and the product rule. The skew polynomial ring Rx theta delta theta is the set of all polynomials over R just like Rx, but in Rx we have Ax equals Xa. In skew polynomial ring, we define Xa to be theta Ax plus delta theta A. We can extend this multiplication to all polynomials. Now we consider a map theta that maps A plus B phi to A plus B minus B phi. This map is an automorphism on R with order 2. Next, we consider the map delta theta like this. This map is a derivation on R. It is easy to prove that delta theta theta plus theta delta theta and delta theta square are always equal to 0. Moreover, if delta theta x equals 0, then x is a fixed point of theta. From the previous results, we have x squared a equals ax squared because theta squared a equals a, and these expressions are equal to 0. Using mathematical induction, we obtain that x to the power of n times a is equal to this expression if n is odd and equals ax to the power of n if n is even. From the multiplication rule, we can easily see that this skew polynomial ring is not commutative. For example, x times 1 plus 3v equals 3x plus 1. It is not equal 1 plus 3v times x. Even though the skew polynomial ring and the usual polynomial ring are different, the skew polynomial ring preserves some properties, such as the right division algorithm. This algorithm is very similar to the usual right division algorithm. Next, I will explain our results regarding the structure of skew linear and skew cyclic codes over R. Let fx bracket be the left ideal generated by fx. Now we define Rn delta theta like this. This Rn delta theta is a left module over the skew polynomial ring with the usual scalar multiplication. This module is isomorphic to Rn. For convenience, every ax plus fx bracket will be written as ax only. We call code C a skew linear code with derivation or delta theta linear code if it is a left submodule of Rn delta theta for some polynomial fx. And then we call a code C a skew cyclic code with derivation or delta theta cyclic code if for all code word in C, we have this code word T delta theta C is also in C. We can identify any polynomial Cx in Rn delta theta with a code word in Rn. In skew linear codes, fx can be any polynomial with degree n, while in skew cyclic codes we only consider the polynomial x to the power of n minus 1. Moreover, we can identify the code word T delta theta C with the polynomial x times Cx. From the definition of skew cyclic codes, we can see that it is equivalent to cyclic codes when theta is the identity map and delta theta is the zero map. It turns out that code C is a skew cyclic code if and only if C is a submodule of Rn delta theta over the skew polynomial ring. If n is even, Rn delta theta is a quotient ring. So the submodule is just ideal. If we add an extra condition of having a basis, the structure of C becomes more simple. If C has a basis, then C is just a module generated by a right divisor of x to the power of n minus 1. Therefore, we can easily construct skew cyclic codes using any right divisor of x to the power of n minus 1. Since the resulting skew cyclic code is free, we can obtain the generator matrix G of C like this. We can also find the structure of the dual. The dual of C is the set of all factors orthogonal to all code words in C. If n is even, we have this commutative property. Moreover, if Cx is contained in C, if and only if Cx times Hx equals 0. From this equation, we can find the parity check polynomial and the parity check matrix of C. In other words, we can find the dual of C using this equation. Finally, I will explain the application of skew codes. From skew linear codes over R, we can construct linear codes over Z4. The definition of linear codes over Z4 is similar to linear codes over R. We write the parameters like this. N is the length for K1 to K2 is the cardinality of the code, and DL is the minimum lead distance. For x in Z4, the Lie weight of x is defined like this. The Lie weight of a factor is the sum of the Lie weight of its coordinates like this. The minimum Lie distance of C is equal to the minimum Lie weight among all non-zero code words in C, like this. Finding linear codes with minimum Lie distance as high as possible for fixed parameters has some real-life applications. We consider the gray image codes where we map every AI plus BI phi to the pair AI plus BI for every I and apply it to every code word of C. We also consider the residue codes where we only take the A part from every A plus B phi in C, and the torsion code when we only take the B part from every B phi in C. These three codes are linear over Z4. Using those constructions, we can construct codes over Z4 using free skew cyclic codes generated by right divisor of x to the power of n minus 1. Here are some examples. Every polynomial in these examples is a right divisor of x to the power of n minus 1. The first code is new linear code over Z4 with the highest possible minimum Lie distance according to the Z4 code database. And the other code have a good minimum Lie distance. We believe many more new linear codes over Z4 can be found from the skew cyclic codes over R. That's all for my presentation. Thank you for your attention.
Okay, thank you. This is the presentation number 4. The next session is the question and answer session. Is there any question for the fourth video or fourth presentation? No? Okay, there are no questions, right? Okay, if there is no question, please give applause for the presentation number 4 for Mr. Joko and for Mr. Hopin Christophen. Okay, we continue with the next presentation, which will be delivered by Mr. Yuki Nishida, from Dosisa University. Okay, Damara, are you ready?
Yes, ma'am.
Okay.
I'm Yuki Nishida from Dosei University, Japan. Today, I'm going to talk about traffic models by fuzzy cellular automata. Cellular automata are dynamical systems on configuration of cells. A simple example is elementary cellular automata called ECA. Cells line up in a row, and each cell has states 0 or 1. We update the state of a cell by the state itself and the left and right side of it. A rule table gives the local update rule like this. In this example, the binary number 10111000 is equal to decimal number 184, so we call this rule ECA rule 184. ECA rule 184 is known as the model of traffic flows. Consider a one-way loop road. Each vehicle moves to the forward side if it is empty. By assigning vehicles with 1 and empty side to 0, the dynamics of vehicles is equivalent to ECA 184. Here are two examples of evolutions of ECA rule 184. Such adjacent block cells means traffic jams. In this case, the jam is resolved, but in this case, jams are never resolved. This difference depends on the density of vehicles. The density is the number of vehicles over the number of sites, and the flow is the number of moving vehicles over the number of sites. Here is a density versus flow diagram called the fundamental diagram. Traffic jams will be resolved in the positive gradient part and will not resolved in the negative gradient part. ECA Rule 184 model does not match real traffic well. A well-known modified model is the slow-to-start model. For example, first, this vehicle moves and stops due to the preceding one. At the next step, this vehicle moves and this site becomes empty. In a ECA Rule 184 model, this vehicle can restart at the next step, but in the slow-to-start rule, the driver first notices the preceding vehicle's move and then it restarts. We can express this model by 3 states 3 neighbor CA. State 0 stands for an empty cell, 1 that the vehicle completely stopped, and 2 that the vehicles that can move. Then this rule table gives the slow-to-start model. The slow-to-start rule is known to show metastability. The fundamental diagram becomes bivalued if the density is between 1/3 and 1/2. This means that the traffic jams may be resolved or may not, even if the density is the same. This also happens in real traffic flows. A fuzzy CA is a kind of continuous valued CA. The fuzzification of ECA is well studied so far. Recently, we proposed the fuzzification of 3-state CA by introducing vector-valued CA. 3 states correspond to the standard basis vectors of 3-dimensional space. Then we can express the local rule by such polynomials. Instead of 3 vectors E1, E2, and E3, we substitute the vectors in this triangle to the function f. Then we can make the fuzzy CA with the state sets, the triangle delta, and the local rule f. We use RGB colors to visualize the evolution of 3-state fuzzy CA. Now, we apply the fuzzification to the slow-to-start model. Here is a polynomial representation of the local rule of the slow-to-start rule. The entry of vectors is the ratio of vehicles that can move, vehicles that cannot move, and empty. Consider the case with no inflow to the site I. We have the outflow of the site I. Then the density of the whole road is this, and the flow of the whole road is this. In most cases, the fuzzification of the slow-to-start model converges to a uniform configuration, like this, although not mathematically proved. If the density is low, then the vector x in the uniform configuration is the rho times 1 minus rho, rho squared, and 1 minus rho. Then the flow is rho times 1 minus rho squared. The fundamental diagram is a red dotted line. We remark that the flow is maximum at 1/3, and metastability also appears at 1/3. The second result in this talk is the extension of the slow to start rule. We consider two kinds of vehicles. One is a slow to start vehicle, and the other is a usual vehicle, like in ECL 184 model. This is a model for trucks and passenger cars. We call this model the mixed slow to start rule. Assigning usual cars to the new state 3, we represent this model by 4 states 3 neighbor CA. We can apply the falsification to the mixed slow to start rule in the similar way to 3 states CA. Here is a polynomial representation of the local rule. Then the density and the flow of the whole road are like these. In most cases, the fuzzy mixed slow to start model also converges to a uniform configuration. If the density is low and the ratio of the usual vehicles to all vehicles say alpha, then the vector in the uniform configuration is like this. Then this is the flow of this model. Fixing the ratio alpha, we have the density attaining the maximum flow. We compare the density rho d, where metastability begins in discrete models, and the density rho f given by this formula. We see that rho d is a little smaller than rho f. This means that the slow to start rule is more effective in the discrete model. Finally, I summarize my talk. First, we extend the slow to start rule by considering two kinds of vehicles. We can represent this model by 4 states 3 neighbor CA. Next, we apply the falsification to the slow to start model and the mixed slow to start model via the vector representation. We construct continuous varied traffic models corresponding to them. The method we introduced in this talk can be used to CA models with any number of states or neighbors, so it will have a wide range of applications. Thank you for listening.
Okay, that's the video presentation for presenter number 5. This is for the question and answer session. Is there any question for the presentation number 5? No, there are no questions. Okay. If there are no questions, please give applause for Mr. Yuki Nishida and all his partner in delivering this video. Okay, thank you. We go to the next presentation. Oh, yes. Who is raised hand in here? Is there anyone raised hand? No?
No,
ma'am. Oh, yeah. Okay. Okay. We continue to the next presentation that will be delivered by Mrs. Sunarsini from Mathematics ITS. Okay. Do you ready, Bramasta? Okay.
Yes, ma'am.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sunarsini. I will present my paper with the title Fixed Point Theorems for two Self-Mappings with New Contractive Condition in Conmetric Spaces. In this paper, I conducted research with the late Professor Erna Apriliani and Dr. Mahmud Yunus. We are from the Department of Mathematics Institut Teknologi 10 November, Surabaya. In this paper, I divided into 4 parts: introduction, preliminaries, main result, and conclusion. Introduction. In 1920, Stephen Penne introduced the theorem of mapping of fixed point to complete metric space. This theorem is known as the Benef contractive mapping theorems or the Benef fixed point theorem. Ritz in 1971 introduced Ritz contractive mapping, and Ritz in 1977 introduced several types of contractive mappings in the complete metric space and proved the relationship between this mapping. Furthermore, Guang in 2007 generalized the metric space of its space structure. He introduced cone metric space. In his research, he proved several Penne fixed point theorems, namely theorems that guarantee the existence and uniqueness of fixed point of Penne contractive mapping in cone metric spaces. Rezapur in 2008 developed the result of Guang by reproving the Penne fixed point theorems in cone metric spaces by eliminating the normality of the cone set, especially cannon contractive mapping. Research on benefit point in cone metric spaces can also be seen in Abbas, Jack, Song, Radonovic, and Srivastava. They examine the fixed point theorem with various variations on the development of two self-mapping. In the current paper, we investigate the existence and uniqueness of fixed point for two self-mappings in cone metric spaces with new contractive condition referring to Radonovic. These two self-mappings are extension of Ritz and Rhodes contractive mapping on metric space. Preliminaries. Definition 1. Let's see subset of E with E be a real Banach space. C is called a cone if and only if C is closed, C is not equal void set, and C is not equal to zero set. If delta epsilon element non-negative real number and xy element of C, then delta x plus epsilon y element of C. C intersection minus C is equal to zero set. Definition 2. Let's see subset of E be a cone. If xy element of E, then a partial order with respect to cone C is defined by x precious or equal to y if and only if y minus x element of C, whereas x precious y means x precious or equal to y, but x is not equal to y. Also, x is much than y means y minus x element of interior of C. Definition 3. Let x is not equal void set. E be a real Banach space and C subset of E be a cone. If the function dc from x cross x to E, C such that for all x, y, z in x satisfy Cm1, Cm2, Cm3, Cm4, and par xdc is called a cone metric space. For example, cone metric space like this. Definition 4. Let xdc be a cone metric space. Let xn be a sequence and xdc and x element of xdc. If for every E element of E, 0 is much than E, there exists n 0 element of n such that for every n is greater than n0 applies dcxn x is much less than E, then xn is called a sequence converts to x. If for every E element of E, 0 is much less than E, there exists n0 element of n such that for every n m is greater than n0 applies the xn xm is much less than E, then xn is a Cauchy sequence in xdc. If its Cauchy sequence is converging in xdc, then X is called a complete cone metric space. Next, we define the coincidence point and weakly compatible for two self-mappings in cone metric space. Definition 5. Given a cone metric space xdc and function ts from x to x, if Sx is equal to Tx is equal to W for some x element x, then X assigned to be a coincidence point of T and S, and W assigned to be a point of coincidence of T and S. Definition 6. Given a metric conspace XDC and function TS from X to X, the pair ST is said to be weakly compatible if STU is equal to TSU, where SU is equal to TU for some U element of X. Main result. We first use development of contractive mapping of rates and new contractive condition with reference to Radon fix. Theorem 1. Let XDC be a complete conmetric space and C a normal conset with constant lambda. If TS from X to X are two commutative self-mapping such that for every XY element of X satisfy like this. If TX subset of SX and S is continuous, then T and S have a unique common fixed point. Theorem 1 can be generalized by eliminating the complete property of XDC and eliminating the commutative property of the two self-mapping. Theorem 2. Let XDC be a cone metric space and C a normal conset with constant lambda. If TS from X to X are two self-mapping such that for every XY element of X satisfy like this. If TX subset of X of SX, SX is a complete subspace of X, then T and S have a coincident point and this point is a unique. If T and S are weakly compatible, then T and S have a unique common fixed point. Furthermore, with the same step and is in Theorem 1 and Theorem 2, we can investigate the existence and uniqueness of two self-mapping by developing the Rhodes contractive mapping and new contractive condition with reference to Radon fix. Theorem 3, let XD be a complete conmetric space and C a normal cone with constant lambda. If T S from X to X are two commutative self-mapping such that for every XY element of X satisfy like this. If TX subspace a subset of SX, S is continuous, then T and S have a unique common fixed point. Theorem 4, let XDC be a cone metric space and C a normal cone with constant lambda. If T S and S from X to X are two self-mapping such that for every XY element of X satisfy like this. If TX is a subset of SX, SX is a complete subspace of XDC, then T and S have a unique coincidence point. If T and S are weakly compatible, then T and S have a unique common fixed point. Conclusion. The Rhodes and Rhodes type contractive mapping in metric space can be extended to two self-mapping in cone metric spaces. By providing a new contractive condition, we can investigate the condition required to obtain the existence and uniqueness of common fit point from the mappings. And my reference like this. Thank you.
Thank you. Now the question and answer session for the presentation that delivered by Mrs. Sunarsini. Yeah. Is there any question for the presentation number 6? No? Okay. If there are no questions for the presentation number 6, we will continue with the presentation number 7, which is delivered by myself. Yeah, I hope you're not boring to listening the video. Okay, please turn on the video, Damara.
Yes, ma'am.
Assalamualaikum warahmatullahi wabarakatuh. Introduce, my name is Soleha. I came from Mathematics Department, ITS. In this time, I will present my paper I'm written this paper with Subiono from Mathematics Department also. Okay. The title of this paper is an algorithm to find near approximations in groups with respect to the normal subgroups. Okay, we begin with the abstract. Okay, near approximation, yeah, has so many development in this time. In this paper, we introduce an algorithm to find the near approximation, or particularly near lower and near upper approximations in groups with respect to the normal subgroups. We consider dihedral group D6 and abelian group Z36. We implement the algorithm in SAGEMAT. Since if we compute manually about the near lower and near upper approximations, the possibility of miscalculation is quite large. The algorithm is become very helpful for computing to show the zero error. Okay, next I will give you some introduction about this paper. Near approximation is related to near set. Near set is introduced by Peters in 2007. Before we know about near sets, there are theory about rogue set that is introduced by Pollack. The difference of rogue set and near set, the near set may also be a null set. And if we talk about algebraic structure in rogue set, it is used one equivalent relation. Okay, in algebraic structure. But in the near set, it is used several equivalence relation. That's why if we talk about near approximation in groups is respect to the normal subgroups, since normal subgroup is associated to some relation, equivalent relations. Okay, the paper that has published in about near approximation, there are Bagimas, also Davas, and Tabozan, and the last year is Davas also. So, what is the main of this paper? This paper is, the aim is of this paper is to find an algorithm to compute the near lower and near approximation in groups with respect to normal subgroups. In Bagimas, in paper number 1, the example of finding the near lower and near upper is restricted only in abelian group. So that's why we construct an algorithm to find near lower and near approximations for non-abelian group, which is permutation group D6, and also for cyclic group abelian group Zn with n greater equal than 12. Okay, this is the material of near approximations in group, which is publication by Bagimas. Like I was said before, we use normal subgroups, several normal subgroups to create equivalent relations in G. Okay, first we have to know about the first definition. If G, V, V is the set of all normal subgroups in G, is a nearness approximation space, then define a partition collection. Okay, you know that equivalent relation is to make a partition of G, right? Families of coset. This is denoted by NRB. NRB, the definition is union of coset of from BR, which BR subset of B, subset of V. Okay. And we also have to use this lemma to find the near lower and near approximation. If G, V is a nearness approximation space, then X BR equal to XBR equal to X intersection of F, which F is in BR. So this is like a coset, yeah, in G. Okay, now we begin with the definition of near lower and near upper. Near lower is denoted with an RPK, yeah. With R is index of P also. The element is X in G such that X BR subset of K. And about near upper, the element is the element of G such that XBR intersection with K is not equal to 0, to empty set. From this definition, we can conclude that NRB lower, yeah, is subset of K and K is subset of near upper, yeah, NRB upper. Okay, I'll give you an example to get more know about the near lower and near upper approximation group. Let G equal to Z12, B is F1, F2, F3 with F1 is 0, 6, yeah, normal subgroups in set Z12, F2 is 0, 4, 8, and F3 is 0, 3, 9, 6, 9. And let K is a subset of G, which is 0, 1, 3, 4, 7, 8, 10. And next we have to find the coset, yeah. Coset of G respect to F1, which is 0, 6. I think it's very easy, yeah? And also about F2 and F3. Then by simple calculation, we obtain NY N1B for R equal to 1, yeah. For R equal to 1, it the union of all coset, yeah, of this coset. So we have here NYB K, the lower, which is the definition is subset of K. So we have to see in here, yeah, see in here, which is the coset is subset of K. The result is 0, 6, no, 1, 7, and also for 10, yeah, 1, 7, and also for 10, and also 0, 4, 8. Okay, 0, 4, 8, and also I think it's finished, yeah. So the near lower is 0, 1, 4, 7, 8, 10. 0, 1, 7, 8, 10. And about the near upper is the coset, which is the intersection with K is not equal to empty set. So we have here 0, 6, etc. We combine this result yield to G itself. So it equal to Z12. Okay, like I was said before that near lower is a subset of K and K is subset of near upper. Okay, we continue with the R equal to 2. The subset of B are F1, F2, F3. Now using by lemma 2, yeah, lemma 2. So the normal subgroup which is we use to find the partition of G, which is F1 intersection with F2. We know that the intersection of two ideals is also ideal, right? I'm sorry, the intersection of two normal subgroups is also normal subgroup. The second normal subgroup is F1 intersection F3 and F2 intersection F3. So by using the same technique for R equal to 1, we have here near lower is equal to K, yeah? Not like in the first area, it's not equal to K, so it more greater, yeah. But for the near upper, it's not equal to Z12 again, but more fewer, yeah, lebih sedikit. Okay, for R equal to 3, this is the result. Near lower is equal to near upper, yeah. So this is finished for this example. Since the normal subgroup R we have picked only 3, so the R equal to 3. Okay, this is for SageMath. Yeah, I choose SageMath since it's free and it's easy to make the comment, and also it can combine with the text, yeah, for publication, maybe other publication. Okay, this is the result and discussion. This is for I choose dihedral group, yeah, to find the near lower and near upper, because it's not abelian group, yeah, for n greater or equal than 3. This is the definition of dihedral. I think it's very common, yeah. And also we have to choose the normal subgroups, yeah. I choose the normal subgroup is F1, F3, and F4. F1, F3, and F4, which is rho is the rotation of 60 degrees, and tau is the flip across the y-axis or the reflection, yeah. It's same. Okay, so this is the algorithm. First, I'll construct the algorithm for R equal to 1, yeah. Define the first step is define the dihedral group with n equal to 6. In this step, you can also substitute n with any positive number greater than 2 to define order Dn. Then we have to define rho and tau, yeah. In this case, rho is permutation 1, 2, 3, 4, 5, 6, yeah. Rotation of 60 degrees, and tau is 2, 6, 3, 5, the flip or the reflection across the y-axis. Then define the normal subgroup, yeah, F1, F3, F4 by using this command, yeah. And then find the right or left coset of each normal subgroups. This for like this example, right? We have to find this coset. And next, define a set that we want to find its near lower and near upper, yeah. Call it set K. Next step, define a list of set which all the right or left coset of the 3 normal subgroups, the union which has been defined in the set. Now, so all the coset we have to combine in a set, yeah. But we have to make it a list, yeah, a list. Okay, to find the near lower, define a list which the elements is the set in step 6 for subset of K is true. You remember that for finding the near lower, the definition is the coset is in K, right? So we have to make common all element in the sets, yeah. Step 6 for subset of K is true. It means that it will yield all the set that is subset of K, right? Okay, but since 2 or more elements of each set in step 7 could be same, yeah. For example, like this example, you see in here that there 4 is appear 3 times, yeah. To make it simple, not to appear in 3 times also, you have to use command set dot union star, yeah. This is filled by the set in here, the set that in the step 7, yeah. The list that is the element which is the subset of K, okay, to make it different for each other. Okay, the result is the near lower approximations in K when R equal to 1. Now we have to find the near upper. Define a list which the elements is the sets in step 6, which the intersection with K is not an empty set, yeah. Based on the definition of near upper. And same like the step 8, we have to use command set union star also to make it different, yeah. For example, we know in here, yeah, 0 is appear many times, 3 times, also 4, also 9. So if you want to make it simple, we have to use this command, yeah. So each element is different, yeah, to each other. So the result is the near upper approximation in K when R equal to 1. Okay, next we have to find the near lower and near upper for R equal to 2 and also for R equal to 3. The technique is same, but you're not using the normal subgroup F1, F3, F4, but the interaction of those normal subgroups, yeah. For R equal to 3, we have to use one subgroup, which is the intersection of all normal subgroups. Okay, it's finished for the case number 1. And for the case, this is the result, the complete result. You see in here, this is the coset, the partition of G, and this is the result. You see that for near lower, the is not equal to K, but for the near upper is equal to G itself. Okay, for R equal to 2, the near lower is equal to K, more greater, and for the near upper is same, is equal to D6. For R equal to 3, it's same, the near lower and near upper is same. Okay, the case number 2, we use Z36, and we also use R equal to 4, not 3, but 4. So there are many normal subgroups, and we have to use the 4 normal subgroups of Z36. This is the algorithm is same with the case 1, but the difference is the comment. I mean, if we define group permutation and cyclic group is quite different, so in define the coset, it's quite different with permutation group. Okay, this is the result, the complete result, for G equal to Z36. This is the normal subgroups, and this is the K is not equal to Z36, and this is the coset, and the result for R equal to 1 is not same with K, it's not equal to K, but the near upper is equal to Z36, and for R equal to 2, it's K, but for near upper is same, but for R equal to 3 is also K, it cannot be more than K, right, for near lower. And for near upper is equal to Z36 minus 5 element, and for R equal to 4 is same, the near lower is same with the near upper. Okay, that's the paper, and this is the conclusion. The algorithm is quite simple but very useful to apply in any n greater or equal than 3 for the hydrogen group Dn, and in any n greater than equal than x for cyclic group Cn. Why I use 3 since D1 and D2 is abelian group, and for n greater than x, we can use more of 3 normal subgroups, if we take n greater or equal than 8. Okay, this is the reference. That's all about my presentation. I hope your comment and also advice for the next, for the better paper. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Okay, that's what about my presentation. Is there any question? No? There are no questions? Okay, if there are no questions in presentation number 7, which is delivered by myself, we continue to the next presentation, okay? That will be delivered by Mrs. Dian Winda Setiawati from Mathematics Department ITS also. Bramasta, are you ready?
Yes, ma'am.
Okay, go ahead.
Okay, I will present my paper on T-row group. Abstract. In this paper, we give a notion of the generalist approximation mapping with respect to a normal subgroup of a group, and some properties of this notion are derived. The notion is an extended notion of the approximation mapping. Keyword: approximation mapping, generalist approximation mapping, normal subgroup. The relation alpha on a non-empty set U is called an equivalent relation if relation alpha, reflexive, symmetric, transitive. This is definition lower row approximation of A. This is definition of upper row approximation of A. The algebraic structure of row set use an equivalent relation that correspond the algebraic structure. The algebraic structure of row set is generalized to the approximation mapping. Furthermore, it's generalized to the approximation mapping with respect to an equivalence relation of the algebraic structure, such as the generalized approximation mapping with respect to an ideal of ring and a submodule of a module. In this paper, we discuss general approximation mapping with respect to the normal subgroup of a group. We give some of its properties. Some of its properties are new, and we show some other ones similar to some of the properties in paper, Mendel and Yamak et al. The new properties are very useful in further research when investigating properties involving two or more normal subgroup of a group. This is definition of upper approximation of A under T. This is definition of lower approximation of A under T. This is definition for T is called a set value group homomorphism if TAB equal TA, TB for all AB in G, and inverse of TA equal T inverse A for all A and G. This is example. T is a set value group homomorphism where Tx equal Xn for every X in G. Generalized approximation mapping in group. In this section, we give a notion of the generalized approximation mapping with respect to a normal subgroup of a group. This notion is adopted from the idea of definition, the generalized approximation with respect to an idea of a ring in Mendel 2013, Yamak 2010. This definition of generalized upper approximation of A under T. This is definition of lower approximation of A under T with respect to the normal subgroup N. This example shows to find generalized lower and generalized upper approximation of A under T with respect normal subgroup N on Z8 and Z20 B group of integer modulo 8 and 20. Proposition 3. The property show if E action in A, then E in generalized upper approximation of A under T with respect normal subgroup N. Lemma 4, Corollary 5, Theorem 6, and Corollary 7 are derived result of Lemma 4.2, Corollary 4.3 in Yamak, Theorem 4.5, and Corollary 4.6 in Mendel 2013. Lemma 4, the properties is relation of lower generalis lower and generalis upper approximation of A with N and X be to normal subgroup of G action such that and subset X. Corollary 5. The property is relation. The properties show relation of intersection upper, generalis upper, and lower approximation of A with generalis lower and upper approximation of A where intersection and intersection X. Theorem 6. The properties show relation of generalis upper and lower approximation of A under T with upper and lower approximation of AN. Corollary 7. The properties show relation of upper, generalis upper, and generalis lower of A approximation of A under T with respect normal subgroup and normal subgroup of G action with upper and lower, generalis upper and lower approximation of AN. Proposition 8. The property is relation of generalis upper approximation of A, generalis upper approximation of B with generalis upper approximation of AB with respect normal subgroup of NX. Properties 8 use AB subset G action. Corollaries 9 use AB a subgroup of G action. So AB equal A. Proposition 8 use N and X be two normal subgroup of G action. Corollary 10 use N be a normal subgroup of G action. So NX equal N. Corollary 9 is similar to proposition 4.6 and corollary 10 similar to proposition 4.5. Yamak 2010. Proposition 11, the property is relation of lower, generalis lower of approximation of A and generalis lower approximation of B with respect to normal subgroup of N and X be to normal subgroup of G action with generalis lower approximation of AB with respect to normal subgroup NX. Proposition 11 use N and X be to normal subgroup of G action. Corollary 12 use N be a normal subgroup of G action. So NX equal N. The following corollary follow from proposition 3, lemma 4, and proposition 11. Proposition 11 use AB subset G action. Corollary 13, AB subgroup of G action. So AB equal A. Subset become equal. Corollary 12 is similar to proposition 4.5 and corollary 13 similar to proposition 4.6 in YAMA 2010. Conclusion: in this paper, we show some properties of the generalist lower and upper approximation mapping with respect to a normal subgroup of a group. Some properties in this paper are new properties. Proposition 3, Proposition 8, and Proposition 11. And some properties are similar to some properties of the generalist lower and upper approximation operator with respect to an idea of a ring. Mendel 2013, YAMA 2010. Thank you.
Okay, thank you for the presentation delivered by Mrs. Dian Windastiawati. Okay, for the presentation number 8, is there any question? No? Okay. If there are no questions, we will continue to the next presentation, which is the topic is about graph, graph theory, which will be delivered by Miss Nirmala Mega Rosida. Okay, Bramasta, are you ready?
Yes, ma'am. Please wait a second.
Hello everyone, let me introduce myself. My name is Nirmala Mega Rosida. I am from Institut Teknologi 10 November Surabaya, Indonesia. I am the first author of this paper and the corresponding author is Sri Nurwati. Now I would like to share to you about the paper of the day. It's about the complement its metric dimension of graphs. First, I will start my presentation from introduction. In the development of graph theory, metric dimensions are still being studied. The metric dimension was first introduced in 1976 by Harari and Meltzer. Along with the development of time, there are new concepts that have been discovered by other scientists. The first concept is the age metric dimension that was introduced by Kellens et al. And the second concept is the complement metric dimension that was introduced by Susilowati et al. In this paper, we construct the new concept, namely the complement age metric dimension on the graph, which is the result of combining these concepts. And we also determine the complement age metric dimension in basic graphs, namely graph Tn or path graph, graph Sn or star graph, graph Cn or cycle graph, and graph Kn or complete graph. The next slide, we present the definition of complement age metric dimension. Let G be a connected graph, M subset Vg be an ordered set, and E is xy element Eg be an H in G. Representation of E with respect to M is denoted by REM and defined as below, where GXM1 indicates the distance from vertex X to M1, and GYM1 indicates the distance from vertex Y to M1. Set M is called a complement edge resolving set of G if any two distinct edges E1, E2 element Eg such that The representation of E1 with respect to Z equals to the representation of E2 with respect to Z. A complement H resolving set of G with maximum cardinality is called a complement H basis for G. Its cardinality is called complement H metric dimension of G and is denoted by adding G. For example, given graph G, then the complement H metric dimension of G is 2. Proof: choose M is V1, V2 subset Vg. Then we can find there are two edges in graph G, namely V1, V4 and V1, V3 have the same representation with respect to M. Thus, M is the H resolving set of graph G. Furthermore, we need to show that the cardinality of M is maximum. Take any Z subset Vg with the cardinality of Z is greater than the cardinality of M. Let's choose the cardinality of Z is the cardinality of M plus 1. Then there are two possibilities which can occur. The first possibility, suppose Z is V1, V2 union X with X element Vg minus M. Without loss of generality, let X is V3. Then we can find every H in graph G has distinct representation with respect to Z. Next, the second possibility, suppose Z is V1, V2 minus X union YZ with X element M and YZ element Vg minus M. Without loss of generality, let X is V1, Y V3, and Z V4. Then, as we can see that every H in graph G has distinct representation with respect to Z. Based on the case described above, Z is not the complement H resolving set. Therefore, the complement H metric dimension of G is 2. Let's move to the next slide. Results. There are 4 theorems. The first theorem, let Pn be path graph with n is greater than 2, then the complement its metric dimension of Pn is 1. Next, the second theorem, let Sn be a star graph with n is greater than or equal to 2, then the complement H metric dimension of Sn is the order of graph Sn minus 2. Next, the third theorem, let Cn be a cycle graph of order n, then the complement H metric dimension of Cn is 1 for n odd and 2 for n even. And the last theorem, let Kn be a complete graph of order n is greater than or equal to 3, then the complement H metric dimension of Kn is the order of graph Kn minus 2. In conclusion, in this paper we have constructed the definition of complement H metric dimension and implemented this definition in graph Pn or path graph, graph Sn or star graph, graph Cn or cycle graph, and graph Kn or complete graph. The exact value of each of these graphs can be found. That's all my presentation. Thank you for your kind attention.
Okay, thank you for the presentation about graph theory, particularly about the metric dimension that is delivered by Ms. Nirmala Megarosida. Okay, next is the question and answer session. If there is a question for the presentation number 9, no? Maybe Javna, you have no question for the presentation number 9? No?
No.
Okay. I want to ask about the presentation. What about I don't know if there is a complement vertis metric. Yeah. What about that? Is there a publication about the topic, or maybe it's not yet? Thank you.
Thanks for your question. I will answer your question. Complement, there are metric dimensions. So in metric dimension, there are a resolving set where M is an ordered set is called a resolving set. If every vertex in G has distinct representation with respect to M. And a resolving set of G with minimum cardinality is called basis, and its cardinality is called metric dimension. But in complement metric dimension concept, there are a complement resolving set of G with maximum cardinality. So in metric dimension, we use minimum cardinality, but in complement metric dimension, we use the maximum cardinality.
Okay. So you use the maximum cardinality, yeah?
Yes, in complement metric dimension concept.
Okay, that's all my question. I want to ask for the other presenters again. Is there any question? No? Okay, if there are no questions, please give applause to presentation number 9. Okay, the next presentation, which is the last presentation, before I ask Mr. Bramasta to play the video, I want to remind you, after the presentation is finished, you may not leave the break room, but you have to take a photograph first all together, and after the photograph is over, you can join the main room. Yeah, you can leave the breakout room and join the main room. Please do not leave the Zoom meeting, yeah, until it's closing, yeah, until closing, because there are announcement for best presenter, yeah, 3 best presenter, yeah, best of the best. I can say best of the best because there we choose from each interest, yeah, research interest, yeah. One for pure and one for applied, and the last from computation. And beside best presenters, there are also best papers, which also came from pure, applied, and computation. Okay, hope great. I will give a great hope for all of you to be the best presenter or be the best paper. Okay, we continue with the last presentation. that will be delivered by Miss Jafna Kamalia Sundusia from Mathematics ITS also. Bramasta, are you ready?
Yes, ma'am. Please wait a minute.
Okay.
Recording in progress. Assalamualaikum. I would like to say thanks you all for coming to my presentation. It's great to see you all. Let me introduce myself. My name is Jafna Kamalia Sundusia and I'm from Institut Teknologi 10 November. I'd like to talk to you today about complement geometric dimension of graph. Introduction. Graph theory is growing rapidly until now. One of the developments in graph theory about resolving set is the discussion of concept of metric dimension. In 1976, in an article entitled On the Metric Dimension of Graph, Harari and Melter introduced metric dimension, which is one of topics in graph theory. Metric dimension is resolving set on G whose cardinality is minimum. A set is said to be a resolving set if every vertex in graph G has a different vertex representation. Representation of a vertex on G is measured based on the shortest path to the resolving set. In terms of operation products or concept of the graph, metric dimension continues to grow. Meanwhile, in terms of developing the concept metric dimension, among other, in 2014, Raffahendra et al. A new idea emerged, namely the bimetric dimension. The development of this bimetric dimension is to determine the representation of its vertex on graph G, which is an ordered pair of the shortest path and the longest path to the resolving set. Furthermore, Susilowati et al. Introduced complement metric dimension. Concept of the complement metric dimension in opposite to concept of metric dimension, in which there is set that answer at least two vertices are considered equal by complement resolving set with half maximum cardinality. While concept of metric dimension by Chartan et al. Is a file set in such a way its vertex in graph has a different representation from resolving set. A set is said to be a resolving set if every vertex in graph G has a different vertex representation. Representation of a vertex on G is measured based on the shortest path and longest path to the resolving set. Bimetric basis is the resolving set with minimum cardinality. Bimetric dimension is number of vertices of bimetric basis of the graph G. The purpose of this presentation is development of a new concept of a type of bimetric dimension of a graph G called the complement bimetric dimension, and give the exact value complement bimetric dimension, where G as a path graph, component graph, cycle graph, star graph, as well as further analysis. Complement bimetric dimension. If every two vertices in VG have some representation with respect to S, is called complement biresolving set of G. Complement biresolving set with maximum cardinality is called complement bimetric basis. The number of vertices of complement bimetric basis of the graph G is called complement bimetric dimension. Example, compact graph order 4. Choose S, V1 and V2. Representation of the shortest path and the longest path to the complement the resolving set S, like the one on the screen. Thus, S is the complement the resolving set. Because in which there is set that answer at least 2 vertices are considered equal by complement the resolving set. Furthermore, we need to show that S is a complement the resolving set with maximum cardinality. With cardinality from M is greater than cardinality from S. Suppose M is V1, V2, and V3. Representation of the shortest path and the longest path to the complement the resolving set M, like the one on the screen. M is not a complement the resolving set because its vertex in graph has a different representation from complement the resolving set. Therefore, complement the metric dimension of complete graph order 4 is 2. Main result. Complement the metric dimension of complete graph is n minus 2, with n is greater than or equal 3. Complement the metric dimension of path graph is 1, with n is greater than or equal 3. Complement the metric dimension of star graph is n minus 1, with n is greater than or equal 2. Complement the metric dimension of cycle graph is 1 if n is odd, and 2 if n is even, with n is greater than or equal 3. Conclusion. In the paper, we have found example value of the complement the metric dimension on some graphs, namely path graph, complete graph, cycle graph, and star graph. So that's it, the end of our presentation today. I will try to answer all questions you have. Thank you so much for your great attention.
Okay, thank you for Ms. Javna for the presentation. Next, we continue with the question and answer session. If there is a question for presentation number 10, it's also about graph. It is also about finding the metric dimension. Yeah. No? There is no question? Okay. So we are done in here to deliver the presentation. I hope that all the presentation give you benefit, yeah, for the future. And please accept my apologize if there is a mistake for joining this parallel classroom, yeah. Okay. Now I will give it time to Mr. Bramasta to direct all the presenter to take a photo. Okay, thank you.
Yes, thank you. So for all the participants, the presenter, I would like for you to all turn on your camera and for a brief minute so that I can take your photo as a commemoration of this parallel class session. Yes. So most of all the participants and presenter have turned on their camera. So I think I will take the photos. You can pose and smile all you like. I will count on 3 to take the photo. I will take on 1, 2, 3. Yes, thank you. I think I will take it one more time. If you want to change photo or if you want to change pose or anything else, please do so. I will take again, and 1, 2, 3. Thank you.
Yes, thank you, Mr. Bramasta, for the contribution in this parallel session. And now, for all the presenter, please, you can leave the breakout room and
Recording in progress.
Departemen Matematika yang berdiri sejak tahun 1965 memiliki dosen yang sangat baik dan berkompeten pada bidang aljabar, analisis, matematika terapan, dan ilmu komputer. Dengan reputasinya yang sangat baik tersebut, kami dipercaya bekerja sama dengan Delft University of Technology, Vienna University of Technology, Sibaura Institute of Technology, dan juga Oxford University. Selain program sarjana, kami juga mengelola program master maupun doktoral.
Recording stopped.
Matematika ITS mendukung penuh mahasiswa dalam kegiatan akademik dan non-akademik. Dengan dukungan tersebut, mahasiswa diharapkan memperoleh pengalaman untuk dapat mengembangkan diri.
Selama saya menjadi mahasiswa Matematika ITS, saya sudah mengikuti berbagai macam kegiatan. Salah satunya yaitu sebagai panitia OMIT atau Olimpiade Matematika ITS tingkat nasional.
Untuk pengalaman Olimpiade, kebetulan saya beberapa kali ikut Olimpiade dari kampus lain, seperti Kalkulus Cup Universitas Negeri Jakarta, terus Olimpiade di Universitas Negeri Malang, di UI, dan lain-lain.
Matematika ITS itu asik, dan di Matematika ITS itu saya punya banyak kesempatan untuk eksplorasi diri. Contohnya, selama aku di Matematika ITS, aku punya kesempatan untuk eksplorasi baik bidang akademik maupun non-akademik.
Sebagai Kasubag Tata Usaha Umum,
di lingkup institusi yang memang stakeholder-nya adalah mahasiswa. Jadi pelayanan yang kami utamakan dalam mahasiswa.
Departemen Matematika ITS memiliki berbagai macam fasilitas yang menunjang proses belajar mengajar. Di antaranya, laboratorium, ruang baca, co-working space, ruang kelas, dan ruang sidang.
Kelima laboratorium ini berkorelasi dengan pusat penelitian yang ada di ITS, pusat unggulan yang ada di ITS, dan pusat kajian yang ada di ITS. Masing-masing laboratorium di Departemen Matematika ITS ini bertanggung jawab kepada mata kuliah yang ada di Departemen Matematika ITS, baik itu di S1, S2 maupun di S3.
Departemen Matematika ITS berkolaborasi dengan instansi lain yang menghasilkan beberapa riset.
Riset ini akan melakukan proses sortir peluru yang cacat menggunakan pengolahan citra digital. Secara garis besar, alat ini akan mengambil gambar atau citra peluru menggunakan dua kamera, yaitu bagian belakang dan bagian selongsongnya.
Proyek tugas besarku ini, aku sedang mengerjakan salah satu program tentang deteksi plat nomor kendaraan bergerak, di mana di sini aku menggunakan metode AI, Artificial Intelligence, yaitu tentang deep learning. Sekarang program ini masih dalam tahap uji coba berupa inputan data video rekaman. Diharapkannya nanti program ini bisa mengerjakan inputan data secara real time dan bisa membantu pihak kepolisian dalam memantau perkembangan lalu lintas.
Departemen Matematika ITS merupakan salah satu departemen matematika terkemuka di Indonesia yang terakreditasi A dan memperoleh sertifikasi ASEAN University Network. Selain itu, Departemen Matematika ITS juga memiliki reputasi internasional dalam bidang matematika dan komputasi.
Oke.
Hai, kamu penasaran nggak sih gimana kampus perjuangan kita tercinta?
Ayo, pakai VR kamu.
Halo semuanya, selamat datang di kampus perjuangan kita tercinta, Institut Teknologi 10 November. Jadi, di kampus perjuangan ini, kalian akan berproses menjadi insan yang dapat mengembangkan inovasi, terutama yang menunjang industri dan kelautan berbasis teknologi informasi dan komunikasi tentunya.
Ayo semuanya, ikut kami yuk.
Gimana? Sejuk kan udaranya? Tahu nggak sih, kalau kampus perjuangan kita itu terkenal dengan ITS Smart Eco Campus loh. Kita di sini percaya bahwa perkembangan teknologi dapat berjalan selaras dengan alam dalam penerapan gaya hidup berwawasan lingkungan.
Nah, kita tiba di gedung rektorat nih teman-teman. Di rektorat ini, kalian bisa bertemu dengan orang-orang penting ITS seperti rektor dan jajarannya.
Kak, kita boleh lihat ke dalam nggak? Ya, seperti yang Nafa bilang, di sini kalian bisa bertemu dengan para pimpinan ITS, mulai dari rektor, wakil rektor, hingga para dekan. Untuk kalian yang punya rencana melakukan pertukaran pelajar ke luar negeri, kalian bisa datang ke kantor ITS Global Engagement di lantai 1 rektorat ini.
Dan kita udah sampai nih di patung ikonik ITS, patung Dr. Angka. Patung ini diciptakan untuk mengenang sosok founding father ITS, yaitu Dr. Angka Nitisastro. For your information, dulu namanya bukan ITS loh, tapi Perguruan Tinggi Teknik 10 November Surabaya.
Kalau itu apa Mbak Mas? Itu kantor Ditmawat dan Dirpendik namanya. Di situ kamu bisa mendapatkan segala pelayanan, mulai dari pengembangan kemahasiswaan, kewirausahaan dan karir, serta layanan kemahasiswaan.
Mbak, udah azan tuh. Kalau mau sholat di mana ya?
Nah, kebetulan banget nih. Kami punya masjid yang super nyaman banget buat kalian teman-teman muslim beribadah di sana. Masjid Manarul Ilmi namanya. Gak hanya tempatnya aja yang luas, tapi segala fasilitasnya seperti tempat wudhu dan toilet juga nyaman digunakan loh. Oh iya, kalau kalian gak bawa mukena, gak usah khawatir. Kalian bisa pinjem kok di sini.
ITS menyediakan 7 fakultas yang bisa kalian pilih loh teman-teman. Untuk kalian yang tertarik ingin berkontribusi dalam pengembangan ilmu pengetahuan dan analitika data yang berbasis teknologi, kalian bisa bergabung dengan Fakultas Sains dan Analitika Data. Kemudian ada Fakultas Teknik Sipil, Perencanaan dan Kebumian, yaitu fakultas yang mempunyai kompetensi dalam mendukung pembangunan Indonesia di bidang perencanaan, pembangunan, dan eksplorasi sumber daya di permukaan maupun dalam bumi dengan tetap memperhatikan pengendalian lingkungan. Kalau kamu tertarik mempelajari pengembangan kreativitas dan pembangunan masyarakat, khususnya dalam bidang desain dan bisnis digital, Fakultas Desain Kreatif dan Bisnis Digital jadi jawabannya.
Fakultas Teknologi Kelautan mempelajari tentang pengembangan pemanfaatan dan transformasi ilmu teknologi kelautan untuk menciptakan pembangunan dalam bidang maritim yang berkontribusi kepada pemberdayaan masyarakat maritim yang berkelanjutan dan ramah lingkungan di kawasan Asia Pasifik. Gak kalah keren dari fakultas yang ada, Fakultas Teknologi Industri dan Rekayasa Sistem hadir untuk kalian yang gemar mempelajari ilmu dasar keteknikan bidang sistem perindustrian, permesinan, komposisi dan teknologi material, sistem instrumentasi, maupun sistematika proses. Selanjutnya, Fakultas Teknologi Elektro dan Informatika Cerdas yang terdiri atas gabungan dari Fakultas Teknologi Elektro yang berfokus pada akuisisi data dan proses transformasinya, serta Fakultas Teknologi Informasi dan Komunikasi yang lebih fokus terhadap hal memproses data hasil transformasi tersebut. Sedangkan Fakultas Vokasi akan memberikan pengalaman kuliah yang berbeda dengan bobot perkuliahan 40% kegiatan yang bersifat teoritis dan 60% kegiatan yang berupa praktek, seperti teknologi rekayasa konstruksi bangunan air, teknologi rekayasa manufaktur, hingga statistika bisnis.
Gak hanya keren di bidang akademis, tapi teman-teman juga bisa mengembangkan diri di bidang non-akademis, misalnya content creation dan broadcasting di ITS TV. Segala informasi up to date bisa kalian dapatkan di kanal YouTube ITS TV. Jangan lupa gabung ya. Sebagai kontribusi dalam menjaga kebugaran mahasiswanya, ITS juga menyediakan fasilitas olahraga seperti lapangan basket ini.
Oh iya, media pengembangan diri di ITS juga banyak loh. Ada BEM Fakultas dan Himpunan Mahasiswa untuk kamu yang tertarik mengembangkan soft skill. Gak hanya itu aja, ITS juga menyediakan kurang lebih 40 UKM di bawah naungan Lembaga Minat dan Bakat yang bergerak di bidang khusus, olahraga, bahkan juga kesenian. Cocok tuh buat memperdalam hobi dan minat kalian masing-masing.
Kak, saya boleh nyoba enggak?
Wah, kamu hebat juga ya ternyata. Tapi nggak hanya berfokus di peningkatan soft skill nih. ITS juga berupaya untuk mencerdaskan aspek spiritual mahasiswanya di bidang keagamaan melalui tim pembina kerohanian Islam, Buddha, Hindu, Katolik, dan juga Kristen. Untuk di tingkat jurusan,
juga terdapat lembaga kajian kerohanian Islam yang berfokus pada syiar kajian Islam. ITS juga tetap memperhatikan kelestarian budayanya loh. Salah satunya lewat UKTK ini. Gak hanya tari tradisional, tapi teman-teman juga bisa mempelajari karawitan dan modern dance.
ITS juga berkomitmen untuk internasional. Ada pusat kajian potensi daerah dan pemberdayaan masyarakat, pusat kajian halal, pusat kajian sustainable development goals, pusat kajian teknologi tepat guna, dan yang terakhir, pusat kajian kebijakan publik, bisnis, dan industri.
Ini dia tempat paling nyaman untuk diskusi dan belajar bareng teman-teman. Selamat datang di Coworking Space ITS. Nggak hanya itu, di sini ada berbagai spot menarik buat teman-teman yang suka dengan tempat yang Instagramable. Hi everyone!
Hai. Selamat datang di kampus ITS. Selamat datang di kampus ITS.
Selamat datang ke ITS.
Sekarang kita sedang menaiki iCar, self-driving car, yang merupakan bukti nyata ITS dalam mengembangkan riset dan teknologi. Gimana? Keren banget kan?
Gimana? Keren kan? ITS ini juga banyak mempelopori penelitian, pengembangan, dan pendidikan dalam bidang robotika loh. Makanya ITS sering banget menjuarai kontes robot nasional dan internasional.
Nah, ini namanya ruang teater perpustakaan ITS. Di sini teman-teman bisa nonton film yang berbeda loh tiap minggunya. Asik kan?
Ya juga banyak dan lengkap banget loh teman-teman. Ada puluhan ribu koleksi mulai dari buku teks, jurnal, majalah, sampai tugas akhir. Layanan corner juga banyak tersedia di sini.
Recording in progress.
Oh iya nih, kalian juga gak perlu bingung mau ngerjain tugas di mana, karena ITS punya banyak banget spot yang nyaman. Salah satunya coworking space ini. Tenang aja, ada wifi-nya kok.
ITS juga peduli terhadap mahasiswanya loh. Bagi kalian yang berasal dari luar kota Surabaya, gak usah bingung mau tinggal di mana, karena tersedia asrama mahasiswa dengan harga yang terjangkau.
Eits, gak cuma itu. Untuk urusan pelayanan kesehatan, ITS juga punya medical center sebagai wujud kepeduliannya terhadap kesehatan mahasiswa.
Teman-teman, kalau kalian mau belajar bahasa, nggak perlu bingung nyari loh. Kalian bisa belajar bahasa asing di UPT Bahasa ini. Teman-teman, rasanya udah cukup ya kampus tour kita hari ini.
Gimana? Sudah tahu kan betapa luas dan lengkapnya fasilitas kampus kita?
Tetap semangat ya kuliahnya, jangan lupa.
Kamu ini dipanggil dari tadi malah sibuk main ini. Ayo, bantu ibu di belakang. Ayo, cepet.
Bu, kampus ITS keren banget loh ternyata.
Loh, kata siapa? Kesana aja kamu belum pernah.
Susah dijelasin. Pokoknya aku udah pernah kesana.
Hai, Kamu penasaran nggak sih gimana kampus perjuangan kita tercinta?
Ayo, pakai VR kamu.
Halo semuanya, selamat datang di kampus perjuangan kita tercinta, Institut Teknologi 10 November. Jadi, di kampus perjuangan ini, kalian akan berproses menjadi insan yang dapat mengembangkan inovasi, terutama yang menunjang industri dan kelautan berbasis teknologi informasi dan komunikasi tentunya.
Ayo semuanya, ikut kami yuk.
Gimana? Sejuk kan udaranya? Tahu nggak sih, kalau kampus perjuangan kita itu terkenal dengan ITS Smart Eco Campus loh. Kita di sini percaya bahwa perkembangan teknologi dapat berjalan selaras dengan alam dalam penerapan gaya hidup berwawasan lingkungan.
Nah, kita tiba di gedung rektorat nih teman-teman. Di rektorat ini, kalian bisa bertemu dengan orang-orang penting ITS seperti rektor dan jajarannya.
Kak, kita boleh lihat ke dalam nggak? Ya, seperti yang Nafa bilang, di sini kalian bisa bertemu dengan para pimpinan ITS, mulai dari rektor, wakil rektor, hingga para dekan. Untuk kalian yang punya rencana melakukan pertukaran pelajar ke luar negeri, kalian bisa datang ke kantor ITS Global Engagement di lantai 1 rektorat ini.
Dan kita udah sampai nih di patung ikon ITS, patung Dr. Angka. Patung ini diciptakan untuk mengenang sosok founding father ITS, yaitu Dr. Angka Nitisastro. For your information, dulu namanya bukan ITS loh, tapi Perguruan Tinggi Teknik 10 November Surabaya.
Kalau itu apa Mbak Mas? Itu kantor Ditmawat dan Dirpendik namanya. Di situ kamu bisa mendapatkan segala pelayanan, mulai dari pengembangan kemahasiswaan, kewirausahaan dan karir, serta layanan kemahasiswaan.
Mbak, udah azan tuh. Kalau mau sholat di mana ya?
Nah, kebetulan banget nih. Kami punya masjid yang super nyaman banget buat kalian teman-teman muslim beribadah di sana. Masjid Manarul Ilmi namanya. Gak hanya tempatnya aja yang luas, tapi segala fasilitasnya seperti tempat wudhu dan toilet juga nyaman digunakan loh. Oh iya, kalau kalian nggak bawa mukena, nggak usah khawatir. Kalian bisa pinjem kok di sini.
ITS menyediakan 7 fakultas yang bisa kalian pilih loh teman-teman. Untuk kalian yang tertarik ingin berkontribusi dalam pengembangan ilmu pengetahuan dan analitika data yang berbasis teknologi, kalian bisa bergabung dengan Fakultas Sains dan Analitika Data. Kemudian ada Fakultas Teknik Sipil, Perencanaan dan Kebumian, yaitu fakultas yang mempunyai kompetensi dalam mendukung pembangunan Indonesia di bidang perencanaan, pembangunan, dan eksplorasi sumber daya di permukaan maupun dalam bumi dengan tetap memperhatikan pengendalian lingkungan. Kalau kamu tertarik mempelajari pengembangan kreativitas dan pembangunan masyarakat, khususnya dalam bidang desain dan bisnis digital, Fakultas Desain Kreatif dan Bisnis Digital jadi jawabannya.
Fakultas Teknologi Kelautan mempelajari tentang pengembangan pemanfaatan dan transformasi ilmu teknologi kelautan untuk menciptakan pembangunan dalam bidang maritim yang berkontribusi kepada pemberdayaan masyarakat maritim yang berkelanjutan dan ramah lingkungan di kawasan Asia Pasifik. Gak kalah keren dari fakultas yang ada, Fakultas Teknologi Industri dan Rekayasa Sistem hadir untuk kalian yang gemar mempelajari ilmu dasar keteknikan bidang sistem perindustrian, permesinan, komposisi dan teknologi material, sistem instrumentasi, maupun sistematika proses. Selanjutnya, Fakultas Teknologi Elektro dan Informatika Cerdas yang terdiri atas gabungan dari Fakultas Teknologi Elektro yang berfokus pada akuisisi data dan proses transformasinya, serta Fakultas Teknologi Informasi dan Komunikasi yang lebih fokus terhadap hal memproses data hasil transformasi tersebut. Sedangkan Fakultas Vokasi akan memberikan pengalaman kuliah yang berbeda dengan bobot perkuliahan 40% kegiatan yang bersifat teoritis dan 60% kegiatan yang berupa praktek, seperti teknologi rekayasa konstruksi bangunan air, teknologi rekayasa manufaktur, hingga statistika bisnis.
Gak hanya keren di bidang akademis, tapi teman-teman juga bisa mengembangkan diri di bidang non-akademis, misalnya content creation dan broadcasting di ITS TV. Segala informasi up to date bisa kalian dapatkan di kanal YouTube ITS TV. Jangan lupa gabung ya. Sebagai kontribusi dalam menjaga kebugaran mahasiswanya, ITS juga menyediakan fasilitas olahraga seperti lapangan basket ini.
Oh iya, media pengembangan diri di ITS juga banyak loh. Ada BEM Fakultas dan Himpunan Mahasiswa untuk kamu yang tertarik mengembangkan soft skill. Gak hanya itu aja, ITS juga menyediakan kurang lebih 40 UKM di bawah naungan Lembaga Minat dan Bakat yang bergerak di bidang khusus, olahraga, bahkan juga kesenian. Cocok tuh buat memperdalam hobi dan minat kalian masing-masing.
Kak, saya boleh nyoba enggak?
Wah, kamu hebat juga ya ternyata.
Tapi nggak hanya berfokus di peningkatan soft skill nih. ITS juga berupaya untuk mencerdaskan aspek spiritual mahasiswanya di bidang keagamaan melalui tim pembina kerohanian Islam, Buddha, Hindu, Katolik, dan juga Kristen. Untuk di tingkat jurusan, juga terdapat lembaga kajian kerohanian Islam yang berfokus pada syiar kajian Islam. ITS juga tetap memperhatikan kelestarian budayanya loh. Salah satunya lewat UKTK ini. Gak hanya tari tradisional, tapi teman-teman juga bisa mempelajari karawitan dan modern dance.
ITS juga berkomitmen untuk internasional. Ada pusat kajian potensi daerah dan pemberdayaan masyarakat, pusat kajian halal, pusat kajian sustainable development goals, pusat kajian teknologi tepat guna, dan yang terakhir, pusat kajian kebijakan publik, bisnis, dan industri.
Ini dia tempat paling nyaman untuk diskusi dan belajar bareng teman-teman. Selamat datang di Coworking Space ITS. Gak hanya itu, di sini ada berbagai spot menarik buat teman-teman yang suka dengan tempat yang instagramable. Hi everyone!
Hai. Selamat datang di kampus ITS. Selamat datang di kampus ITS.
Selamat datang ke ITS.
Sekarang kita sedang menaiki iCar, self-driving car, yang merupakan bukti nyata ITS dalam mengembangkan riset dan teknologi. Gimana? Keren banget kan?
Gimana? Keren kan? ITS ini juga banyak mempelopori penelitian, pengembangan, dan pendidikan dalam bidang robotika loh. Makanya ITS sering banget menjuarai kontes robot nasional dan internasional.
Ini namanya ruang teater perpustakaan ITS. Di sini teman-teman bisa nonton film yang berbeda loh tiap minggunya. Asik kan?
Ya juga banyak dan lengkap banget loh teman-teman. Ada puluhan ribu koleksi mulai dari buku teks, jurnal, majalah, sampai tugas akhir. Layanan corner juga banyak tersedia di sini.
Oh iya nih, kalian juga gak perlu bingung mau ngerjain tugas di mana, karena ITS punya banyak banget spot yang nyaman. Salah satunya coworking space ini. Tenang aja, ada wifi-nya kok.
ITS juga peduli terhadap mahasiswanya loh. Bagi kalian yang berasal dari luar kota Surabaya, gak usah bingung mau tinggal di mana, karena tersedia asrama mahasiswa dengan harga yang terjangkau.
Eits, gak cuma itu. Untuk urusan pelayanan kesehatan, ITS juga punya medical center sebagai wujud kepeduliannya terhadap kesehatan mahasiswa.
Teman-teman, kalau kalian mau belajar bahasa, nggak perlu bingung nyari loh. Kalian bisa belajar bahasa asing di UPT Bahasa ini. Teman-teman, rasanya udah cukup ya kampus tour kita hari ini.
Gimana? Sudah tahu kan betapa luas dan lengkapnya fasilitas kampus kita?
Tetap semangat ya kuliahnya, jangan lupa.
Kamu ini dipanggil dari tadi malah sibuk main ini. Ayo, bantu ibu di belakang. Ayo, cepet.
Bu, kampus ITS keren banget loh ternyata.
Loh, kata siapa? Kesana aja kamu belum pernah.
Susah dijelasin. Pokoknya aku udah pernah kesana.
Hai, kamu penasaran gak sih gimana kampus perjuangan kita tercinta?
Ayo, pakai VR kamu.
Halo semuanya, selamat datang di kampus perjuangan kita tercinta, Institut Teknologi 10 November. Jadi, di kampus perjuangan ini, kalian akan berproses menjadi insan yang dapat mengembangkan inovasi, terutama yang menunjang industri dan kelautan berbasis teknologi informasi dan komunikasi tentunya.
Ayo semuanya, ikut kami yuk.
Gimana? Sejuk kan udaranya? Tahu nggak sih, kalau kampus perjuangan kita itu terkenal dengan ITS Smart Eco Campus loh. Kita di sini percaya bahwa perkembangan teknologi dapat berjalan selaras dengan alam dalam penerapan gaya hidup berwawasan lingkungan.
Nah, kita tiba di gedung rektorat nih teman-teman. Di rektorat ini, kalian bisa bertemu dengan orang-orang penting ITS seperti rektor dan jajarannya.
Kak, kita boleh lihat ke dalam nggak?
Ya, seperti yang Nafa bilang, di sini kalian bisa bertemu dengan para pimpinan ITS, mulai dari rektor, wakil rektor, hingga para dekan. Untuk kalian yang punya rencana melakukan pertukaran pelajar ke luar negeri, kalian bisa datang ke kantor ITS Global Engagement di lantai 1 rektorat ini.
Dan kita udah sampai nih di patung ikon ITS, patung Dr. Angka. Patung ini diciptakan untuk mengenang sosok founding father ITS, yaitu Dr. Angka Nitrisastro. For your information, dulu namanya bukan ITS loh, tapi Perguruan Tinggi Teknik 10 November Surabaya.
Kalau itu apa, Mbak Mas?
Itu kantor Ditmawat dan Dirpendik namanya. Di situ kamu bisa mendapatkan segala pelayanan, mulai dari pengembangan kemahasiswaan, kewirausahaan dan karir, serta layanan kemahasiswaan.
Mbak, udah azan tuh. Kalau mau sholat di mana ya?
Nah, kebetulan banget nih. Kami punya masjid yang super nyaman banget buat kalian teman-teman muslim beribadah di sana. Masjid Manarul Ilmi namanya. Gak hanya tempatnya aja yang luas, tapi segala fasilitasnya seperti tempat wudhu dan toilet juga nyaman digunakan loh. Oh iya, kalau kalian gak bawa mukena, gak usah khawatir. Kalian bisa pinjem kok di sini.
ITS menyediakan 7 fakultas yang bisa kalian pilih loh teman-teman. Untuk kalian yang tertarik ingin berkontribusi dalam pengembangan ilmu pengetahuan dan analitika data yang berbasis teknologi, kalian bisa bergabung dengan Fakultas Sains dan Analitika Data. Kemudian ada Fakultas Teknik Sipil, Perencanaan dan Kebumian, yaitu fakultas yang mempunyai kompetensi dalam mendukung pembangunan Indonesia di bidang perencanaan, pembangunan, dan eksplorasi sumber daya di permukaan maupun dalam bumi dengan tetap memperhatikan pengendalian lingkungan. Kalau kamu tertarik mempelajari pengembangan kreativitas dan pembangunan masyarakat, khususnya dalam bidang desain dan bisnis digital,
Good afternoon, ladies and gentlemen. Welcome back to the International Conference on Mathematics, Pure, Applied, and Computation, or ICoMPAC 2021. We've been through several agendas for today, and we hope you enjoyed today's event. And now, we finally arrived at the closing ceremony of ICoMPAC 2021.
Furthermore, we would like to present an award for the best paper and presenter. I would like to invite the head of Mathematics Department ITS, Subhan PhD, to give the award. Bapak Subhan, the time is yours.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, ladies and gentlemen. I believe that during this conference, all of us have obtained a fruitful discussion. In this international conference on mathematics, pure, applied, and computation, or we call it ICoMPAC 2021, whose main theme is mathematics of quantum computing, we have learned a lot from the keynote sessions, which delivered by the amazing keynote speakers who have shared their interest work. Once again, on behalf of the committee, thank you for delivering such important material so that all of us can deepen our knowledge. Furthermore, I would like to thank all presenters, participants who have joined this conference from all over the world. I am certain that every presenter has presented their research. I sincerely hope that through your presentation and discussion, all of us can contribute for our better future. Even though the contribution may be small, but it is still valuable. The next thing I would like to say, we are happy to announce the best paper and also the best presenter award. The best paper award is with the title Behavior of Logistic Map and Some of its Conjugate Map by Ahmad Teddy Ruslan, Marwan, and Quratul Aini. The second one is Traffic Flow Model with two kinds of vehicle in terms of the vector valued cellular automata and their falsification by Yuki Nishida, Sanosuke Watanabe, Akiko Fukuda, and Yoshihide Watanabe. And the third best paper with the title A Mathematical Model of Fowl Pox in a chicken farm with isolation and fumigation by Sikin Fadila and Dipo Aldila. Yeah, yes, the second one, yeah. The next one, please. Okay, now I will announce the Best Presenter Award. The first one is Structural Properties of Skew Cyclic Code of a Finite Ring by Joko Supriyanto and Hook-in Christophen Tang. Second, implementation of genetic algorithm method for stochastic model of COVID-19 in Indonesia by Aldi Widianto, Amirul Hakam, Sentot Suryanto, and Endah Putri. The third one is calendar variation model for ticket sales forecasting at Kayangan Port, East Lombok by Aris Aswadi, Mustika Hadiyati, and Igede Wisnuwardana. Congratulations. Finally, I would like to thank all the committee members for organizing this conference and ensuring that it proceeds smoothly. I would like also to apologize for any inconvenience that you might experience during this conference. Ladies and gentlemen, finally, I do also hope that we can meet again, inshallah, in ICoMPAC 2022. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Congratulations to the award recipients. And once again, thank you very much for conducting this amazing session, for the excellent presentation, and also the insight and knowledge that you've given and you shared with us.
Now, the awarding session is the end of our event today. Finally, ladies and gentlemen, we have reached the end of today's event. Thank you very much for coming to the International Conference on Mathematics, Pure, Applied, and Computation, or ICoMPAC 2021. My name is Samarah Rana.
And my name is Admiralitik. And we sincerely apologize for any mistakes that we may have made in presenting as the masters of ceremony. Thank you very much to ITS officials, special guests, and participants for your kind attention and cooperation. Good afternoon, and see you at the next ICoMPAC.
Thank you very much. Thank you very much.
Thank you, Bapak Ibu.
Terima kasih, matur suwun, matur suwun.
See you next year. Hopefully we can meet offline, guys. Bapak Ibu semua.
Amin, 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 amin.